Okay, good afternoon, everyone, and welcome to PyCon. This is the largest conference I've been to in like 3.5 years. It's very exciting. So today, I'm going to be teaching you all about data analysis with SQLite and Python. And for this session, I've prepared a very extensive handout, which I'm going to be working through, which is available right now online. So if you go to SQLite-python-pycon-2023.readthedocs.io, I'm now regretting not getting a shorter URL for it. This will give you the exact notes that I'm going to be working through for the workshop today. We have two volunteers at the back, Felix and Nick, who are waving there. If you get stuck with anything, please put up a hand, and one of them will scoop in and hopefully rescue you. I'm hoping this should all be quite straightforward. One of the great things about SQLite in general is that there are very little things that can go wrong with it. The development environment you'll be using today should be, I'm going to regret saying this, should be rock solid and hopefully won't cause us any problems. And yes, so the plan for today is we're going to talk about SQLite and Python and how to use those just straight out of the standard library. I'm going to introduce you to Dataset, the tool that I've been building for the past 5 years now to help with sort of data exploration, analysis, and publishing. I'll also talk you through SQLite Utils, which is a library I've been building to make working with SQLite as productive as possible. We will publish a database onto the internet. That's going to be fun. I'll show you Dataset Lite, which is Dataset running inside of WebAssembly in a browser, which I still, to this day, can't believe that's possible. And then we'll talk about some advanced SQL topics towards the end as well, and lots of demos and all sorts of bits and pieces like that. One thing I'm going to be sort of tangentially covering is SQL itself. And that's because I've decided to do this in sort of board game rules. And if you've ever played a new board game, there are two ways you can do it. You can dissect all of the rules at the very start, and everyone figures them out, and then you start playing. Or you can just start playing and pick up the rules as you go along. And I'm hoping that we can do that with SQL. So if you're familiar with SQL, you're going to be fine. If you're not familiar with SQL, hopefully you'll be able to pick up bits and pieces as and when we need them as we go through the tutorial. So in terms of what you'll need, for the first half of this tutorial, you will need nothing more than Python 3 running on your laptop, or running on a device. That's it, nothing else. Everything will be based on things in the standard library. Once we get past Python, you will need the ability to pip install stuff. So if you know how to use virtual environments, and if you've got an environment you can pip install into, you'll be completely fine. Just in case anyone's not set up for that, I'm going to be running this tutorial myself using GitHub Codespaces, which offers a free development environment entirely in the browser. The thing I love about Codespaces is that if it breaks, you throw it away and you open up a new one. So it's sort of ideal for things like tutorials, where the last thing you want to do is get into a state where your development environment isn't working, and now you lose time trying to fix it when you could be getting on with the thing that you're trying to learn. So, first, a show of hands, who here has Python 3 running on a laptop and is already happy with that? Okay, is there anyone who doesn't and is going to join me in using Codespaces, which I'm going to use anyway? There we go, we have one, fantastic. Okay, so what I'm going to do is I'm going to start with this repository here. This is a repository that GitHub themselves shared that gives you a really quick way to get into a Codespaces environment with Jupyter Notebook set up as well. So I can say, use this template, open in a Codespace, and this churns away for a few seconds. It's somewhere it's launching a Kubernetes container and all sorts of stuff, but I don't really have to care about that. And now, here we go. This is a brand new development environment that I can start working in, at least once it finishes booting up Linux and so forth. I'll leave that. Oh, here we go. Codespaces Jupyter. Problems, output terminal. There's an animated GIF here that shows the sort of faster version of this for people who want to try this out themselves. And now I've got a cursor, and here we are. This right here is a full-blown like Linux installation with Python and all of the bits and pieces that I'm going to need. And I'm going to bump that font size up a lot. I'll get rid of this. Let's do export PS1 equals $space There we go. So now if I run Python 3, I've got Python 3.10, which is everything that I should need for the first section of this tutorial. So I did export, hold on. I did export PS1 equals, and then $, in the space. And that just renames the start of my thing so that when I've got a big font, I don't have half the screen taken up with the directory path. So what happens if I run Python? Oh, just running Python gets me Python 3 as well. So we're going to start by talking a little bit about SQLite itself. Does anyone here use SQLite on a regular basis at the moment? A few people. I'm going to turn the rest of you into converts. That's my goal for the day. So SQLite is a fascinating little piece of technology. I think it's often not given the respect that it deserves. I think part of that's because the name suggests that it's a lightweight database. It turns out it's actually named after stalactites and stalagmites. The LITE wasn't the goal when D. Richard Hitt released the software in the first place. But the unique thing about SQLite is it's been around for at least 20 years now. And it's an embedded database. It's not like Postgres and MySQL run on servers somewhere and you have to talk to them over a network. SQLite is a C library that you import into your program. And anytime you're talking to the database, you're actually just making C-based function calls to a file on disk, which means it's screamingly fast. Like, it doesn't have any of the overhead of sending SQL queries back and forth. And it's surprisingly powerful in terms of what you can do with it. There we go. It's also been built into Python since 2006. Like, this is and anyone who has installed Python anywhere in the world actually has SQLite as a database just sat there waiting for them to import it and start using it. So this is not a new technology in the world of Python by a very long way. It's not just Python. It's got bindings for Go and Ruby and Perl, and any programming language you like can talk to SQLite. And it's also got really strong backwards compatibility to the point that the Library of Congress has announced that SQLite is one of the few structured data formats that they consider of archival quality for the work that they do. If you put data in a SQLite database, future versions of SQLite are effectively guaranteed to be able to open it again. So it's actually it's a great default place to put data. My absolute favorite thing about it, a SQLite database is a file. Like data.db. It's a file on disk. It's a single file which will work on any platform. You can send it over to an ARM machine or a 486, or somebody reported a bug in dataset on some IBM mainframe that I'd never even heard of, but it could run SQLite. But that single file can hold pretty much anything you could possibly want to stick in there. You can put in, it does text and binary data, integers and floating point numbers. It's got really good support for JSON. And the end result is that any data of any size, anything you could possibly imagine, you could fit it into that single file. It's almost like a zip file that you can run SQL queries against. So super, super powerful. Also, these days, the maximum size of a SQLite database is 2.8 terabytes. About a year ago, it was 1.4 terabytes, and then someone in the world has a database that's too big for that, and they reported it to the SQLite maintainers, who doubled that maximum size. So now, if you've got less than 2.8 terabytes of data and a disk big enough to put it, you can stick that in a SQLite database. And it also has some very interesting characteristics of its own. One of my favorite examples of that, there's this essay on the SQLite database, Many Small Queries Are Efficient in SQLite, which points out that with MySQL and Postgres, if you've got a web page with 200 SQL queries on it, you're in trouble because that's 200 round trips back and forth to your database server. With SQLite, 200 SQL queries is 200 function calls. So actually, once you get used to that, you start using it in a very different way from other databases. It's okay to have n+1 queries, loop through all 200 things and do an extra query for each one. That kind of thing just works, which is fascinating. I've been using SQLite for most of my work for the past 5 years, and I still feel like I'm not taking full advantage of this bizarre characteristic of that database. But let's actually start using it. So I'm going to suggest we start with an example database. If you run wget or curl, or you'll click it in the browser to grab dataset.io/content.db, that will give you the SQLite database that powers the official Dataset website. So this website right here has news and plugins and all sorts of bits and pieces. Those are sat there in a SQLite database, which you can just download right now to start working with it. And so I'm going to do that in my code space. Where is it? Here we go. Let's do wget dataset.io/content.db.
For curl users, you don't have wget, you can do curl -capital O, and you give you the same result.
That's a great tip. Yep, curl-O will get you. Hold on, I need to shrink my window so it's not behind my little sticky note. Curl-O. Ooh, will that work for dataset without the HTTP, I wonder? Oops. I think it didn't work because I already had the file. But anyway, that will give you a SQLite database. It's, oh, no, I overrode it. Hang on, let's do that one more time. Aha, if you do curl without the HTTPS, it downloads the HTTP redirect page, I think, which is blank. HTTPS ://. There we go. And that has given us a 17 megabyte file. So now I'm going to start playing with it in Python. We can fire up Python again. Import SQLite 3. That's straight out of the Python standard library. And then to connect to a database file, you just pass it as the path to the SQLite3.connect method. And this gives us a SQLite connection. Actually, I'm going to go off script a moment. The first thing I always do with these things is I want to see what the tables are that are present in there. I can do that by saying select star from SQLite master, which is the metadata database that SQLite gives you for free. Fetch all. Actually, I think I probably want to do select name from SQLite master where type equals table. There we go. And that right there is a list of all of the tables in my database. We'll do this line here too. This is the SQLite version function. This demonstrates that SQLite has functions. Will tell you what version of SQLite you're running. I'm on 3.31.1, which I think is pretty recent. That's within the last 12 months that release came out. What I'm doing here, when I call db.execute, I give it a SQL query. It gives me back a cursor object. One of the things you can do with the cursor object is called .fetchAll, which then fetches a list of all of the rows from that. And then each of these lists, each of those rows comes back as a Python tuple. So I've got a Python tuple with the result of that single function call right there. And we can also do this. So I'm going to do the cursor object acts as an iterator, so you can loop through it directly and print out each of those rows. So let's do that now. There we go. And again, each of those came back as a tuple. The column, the database table I'm selecting here just has 3 columns, so we get 3 values back. Tuples aren't particularly readable if you're mucking around trying to figure out what's going on. So you can instead say db.row_factory equals, and then give it a factory function that we used to create the returned objects from those rows. SQLite3.row is a built-in mechanism that gives you a weird sort of half tuple, half dictionary object that you can work with. So if I put that in and then do this one again, oh, now I'm getting row objects, which that's not crazy useful, but you can call the dict function on those rows and get back dictionaries. So this is a very lightweight way to start turning those SQL results into lists of dictionaries, which you can then start working with really easily. Let's take this a step further and actually create a database table of our own. So SQLite's version of SQL is heavily inspired by Postgres. So if you're familiar with Postgres, a lot of the things you know from Postgres will work more or less the same in SQLite. One of the biggest differences with SQLite is it has a much more restricted set of column types, which I really love. Like when I'm working with databases, one of my least favorite bits is when you think to yourself, should I have the title as a varchar 100, or maybe it needs to be a varchar 255? All of those kinds of questions. With SQLite, those just go away. You can say everything is going to be either, I've got a section down at the bottom here, it's either going to be text or an integer or a real, which is a floating point number, or a blob for binary data, and that's the whole thing. So it's very, very easy to make decisions about how we're going to how we're going to create those tables. So the table I'm going to create right now is one to hold Python PEPs, PEPs, the documents the documents that define how Python works and how the Python community operates. And I've just selected a subset. I'm going to give them an ID, a title, author, status, type, created, and body. We'll see the data for those in a moment. So I can paste that into here, and that's created my table. And if I was to run that table thing from earlier on, this one here, oh, look at that, it's showing me rows now. Let's do dict r for r in. There we go, we now have a brand new table at the very end called PEPs. So now that we've created a table, we're going to drop some data into it. I decided it would be more interesting if, is there a way to hide this navigation, I wonder? Doesn't look like there is. I decided it would be more fun to actually work with real data for this, so I got GPT-4 to write me a quick function to turn a PEP into a Python dictionary. This is a perfect example of the kind of code that I could have written in 2 minutes, but GPT-4 wrote in 15 seconds, so it saved me a whole minute and a half of time. So I'm going to paste that function in. This is my parse_pep function. And then I'm going to grab a copy of one of the greatest PEPs of all time, The Zen of Python by Tim Peters, published in 2004. Wow, it's nearly 20 years old now. That's, have to have a birthday party for it next month. And as you can see, the format of this file is a bunch of key value pairs at the top, and then the rest of the file comes afterwards. So it's very easy to write a parser for it. I'm going to import URL-lib and do this to get that PEP into a dictionary. Oh, did I mean, what happened there? URL-lib has no attribute request. That doesn't sound right. Okay, it worked. I had to change that to import URL-lib.request. And so now I've got the contents of that text file. I just printed out a summary version of it so that we could see that. And if I run parse pep on the Zen, I've now got a Python dictionary with keys pep, title, author, status, type, content type. So our next step is to insert that into our database. And this is, we will not be doing much more of this for the duration of the tutorial because my SQLite utils library puts a sort of layer of syntactic sugar over the top of this. But generally, when you're working with SQLite, the way you run queries like this is you have the query as a string with placeholders for the values that you want to inject into that, and then you pass those values as a list or tuple afterwards. So in this case, we want to insert into the ID, title, author, status, type, created, body columns the values that we got back from that PEP. The reason we do it like this is to avoid SQL injection problems, where if we tried to glue the string together with double quotes or single quotes, quotes inside of those values might have interfered with that and broken our SQL. So you should always parameterize queries in this way anytime you're working with data from another source. So here we go. I'm going to paste that in. And now we should have a PEP in our database. Let's run select star db.execute select star from peps.fetch all, and we'll wrap that in a dict. And there it is. Our PEP is now inside of our SQLite database, which is kind of cool. That was a pretty lightweight way of getting that data into a format where we can query it. I do want to demonstrate an alternative way of doing these parameters. Here we had to put question marks and then pass things in as a sequence. You can also use colon syntax for named parameters and then pass a dictionary directly to c.execute as well. So I'm going to delete that file. I'll delete the PEP that I just inserted. Check that's been deleted. Yep, the SQL query there failed to retrieve it. So the question is, when do you use triple quotes versus single? So triple quotes let you split your string over multiple lines. That's the only difference between triple quotes and single quotes is you get multi-line strings. And I find just for SQL queries, it's more readable if you can see it spread across multiple lines than if it's just a single line. Okay, I'm going to run that again, and once more, we've now inserted that dictionary directly into that query, and we've inserted it back into our table. An interesting thing about SQL is that, to be honest, there's very little that you need to know in order to use it productively. We've done create table. That's obviously important. You need to create tables to put your data in. We've seen what an insert looks like. There are two more things to know. There's updates and deletes. So an update is a way of updating an existing row. In this case, I think the row that we've got right now has Tim Peters as the author. Let's see, pep.keys. So yeah, it's got Tim Peters with his email address. I'm going to update that to remove the email address. I'll do that by pasting this in here. There we go. And now, if I do db.execute select author from paps.fetch all dict. And you can see that now I've updated the author to be Tim Peters instead of Tim Peters with the Gmail address. This example here does use one other trick. SQLite is a relational database that supports transactions, so you can bundle up changes in a block of code and then make them all available at once to other people who might be querying that database. And there's a nice little thing in the Python SQLite module where you can use the context manager and say with db : and then anything indented inside of that block will be run inside the same transaction. So this is a good habit to get into when you're making modifications to a database, because it means that you don't really have to think very hard about how transactions are working. You just sort of stick to this pattern and everything should work okay. The update there, I'm saying update peps set author equals blah, where ID equals blah, and again, using those placeholders. So this ends up being update peps set author to Tim Peters, where the ID is 20. The with is not. No, the with there is that's the Python context manager. If you were using SQL, I think you'd do commit semicolon, but to be honest, I've never done it in Python because I always use this mechanism instead. And then finally, to run deletes, very similar. Delete from peps, where our ID equals question mark. So I'm going to delete row 20. And having done that, now if I run that query again, I don't get back any records. And if you can delete with where queries and delete everything and things like that as well. But what I like about this is that we've basically covered 90% of the data manipulation language aspect of SQL that we need to care about. You create tables, you insert rows into them, you update them, you delete them. Almost everything else you do will be in the much more rich and complicated area of writing select statements. And that's the bit that we'll be applying board game rules to and picking up bits and pieces of that as we go along. So this is because when you have question marks in your query, that's saying that you're going to pass a list of parameters to it. And in this case, normally most of the time we've used multiple question marks, so it makes sense to pass a list of multiple ones. You know what? It's possible that this will work without being in a list. I've not actually tried. Let's see.
So why don't you just put ID equals 20?
It's purely out of habit. You absolutely could do that in this case, where ID equals 20 would work fine. But then you're getting to a stage where, okay, do we start gluing strings together to construct that SQL query, which is a dangerous pattern, because if you do that with non-integers, you might end up accidentally injecting bits of SQL you didn't mean to into your query. And I mentioned transactions earlier. Oh, hold on. Oh, no, that is working. If you're interested in exploring transactions a little bit further, there's an exercise here where you can see how those transactions are only visible to other processes after they've been committed. I'm going to skip over that now because I think it's more fun to get onto the next section. So that's Python SQLite.
So when you create a connection, those transactions will be on that one connection.
Exactly, yes. Yeah, oh, that's a really good point. Yeah, one of the interesting things about transactions is you can have multiple connections to a SQLite database from within the same Python program, and changes in one will only be visible to the others after you've committed those transactions. Let's do something a whole lot more fun. I'm going to drop us out of regular Python, and we're going to start using the tool that I've been building for the past few years called Dataset. So the way you install this is you run pip install dataset, or if you prefer pipx, you can use pipx. There's homebrew packages. There are many different ways that you can install it. Pip install dataset will work just fine for the most part. And having done that, you get a new command called dataset. Oh, hold on. Let's do dataset version just to make sure that worked. There we go. So I've just installed dataset version 0.64.2. So Dataset is a command line utility that starts a web server running against a SQLite database. In this case, we're going to say dataset content.db and hit enter. And this will then start a web server running on port 8001. And in GitHub Codespaces, it has a feature where it spots when that happens and gives you the option to open that in a new tab. So this is one of the reasons I love GitHub Codespaces. It makes all of this stuff work. And so now, I click that URL, and I've now got access to Dataset, except, I was expecting this to break, actually. I just remember that there's one extra step that I need to do. But we'll continue, and if it breaks, I'll fix it when that happens. So this right here is the Dataset web application. By default, it gives you an interface to explore any SQLite database that you care to give it. So this is our content database that we've been working with. And whereas previously we were running code inside of Python and sort of squinting at lists of strings, now we can scroll down and see all of the tables that are in that database. Oh, there's our PEPs table, except it hasn't got any data in it. That's annoying, because I deleted the data and forgot to put it back. So I'm going to pop back to Codespaces. I'm going to run Python again. Oh, this is frustrating. Drop in my parse pep thing. Go. Let's import urllib.request. Import urllib.request. db equal import SQLite 3.connect. What was it called? Content.db. And now I can run this thing here, and we should be back to where we started. There we go. Okay. So now if I run dataset on content.db again, this time I forgot to commit. I forgot to commit my change to the database. You know what? I'm going to leave that. And if you didn't delete the data, then you should have that row in your local database as well. But I've got all of these other tables. So these right here are the tables that power the official Dataset website. One of the most interesting tables in there is one called repos, which is all of the... So the reason I got that error is I forgot to install one additional plugin. This should be in the documentation. Yes, in GitHub Codespaces, there's an additional plugin you need to install to make sure you avoid those kinds of errors. And that's this one here, dataset install dataset-codespaces. And having done that, now this should, here we go. So this right here is a database of all of the GitHub repositories that form the overall dataset project. And it's 158 because there's a lot of different plugins and tools and associated things like this. The data in here is actually created by another tool I wrote called GitHub to SQLite, which can import data from your GitHub account and use it to populate a SQLite database. And this is a pattern that I use a lot. If you go to the dataset website and look in the tools database, you will find things like Swarm to SQLite and Apple Notes to SQLite and GitHub to SQLite. Because once you realize how flexible SQLite is, you kind of want everything in your life to be in it so that you can run queries against it and join it against things and run data set against it. So I've spent the last few years accumulating all sorts of weird little tools that will take things from some API or some source of information and stick them in a SQLite database so I can then start using them with dataset and other tools like that. I've actually got one in here called Genome to SQLite, which can import a copy of your genome into a SQL database, which means I know what color my eyes are with a SQL query, which is super useful, really exciting. But yeah, so we're going to grab another database for the next section. I'm going to,
You mentioned that it's very similar to Postgres. Is it easy to import database from this to Postgres?
So I don't have a route to go from here to Postgres yet, but I have a route to go in the other direction. So I have a tool I wrote called DB to SQLite, which can be uses SQL Alchemy and can be pointed at a Postgres or MySQL database, and will create a SQLite database as a backup of those databases. And I've got a demo I'll show you later on where I've done exactly that with a Postgres database that I do a lot of work with. So we're going to grab one more database. We're going to grab this one here. This is a database of congressional legislators. It's people who are Congress people or senators or presidents and vice presidents. It's this wonderful open source project where people have been gathering information on how Congress has been structured right back to 1793, I think. So if you're building demos for database software, this is an absolute goldmine. And what we're going to do again is we're going to grab a link to that database. This one's just 5.2 megabytes. And you know what? I'm going to open up an additional terminal so I can leave dataset running. Export PS1. There we go. So I'm going to grab that as well. And then I'm going to restart dataset to run against my new legislators database. So having done that, I've now got, ooh, what happened there? Surprising. Here we go. So I've now got a content database and another one called legislators. And that's got tables for legislators and executives, that's presidents and vice presidents, and when they were in office, and their names and their birthdays and all sorts of bits and pieces like that. It's a really fun example database for playing around and learning things like SQL. So in a moment we'll so for the next step, if there's a link from this document here to one of the official dataset tutorials, which effectively introduces dataset and the dataset interface in terms of this congressional legislators data. You're welcome to run this on your own copy of the database. You can also go straight to the hosted copy of the database here as well, if you haven't managed to download that file. And this will take you through a whole bunch of useful features of dataset itself, so I'll review that right now. One of those features is that dataset it'll give you a table of data, and you can do things like sort that by district, or actually it probably makes more sense to sort by start date. So I can sort start date ascending. I can see that in this database here, we've got 44,000 legislative terms. The earliest was 1789. When the anti-administration party had, that's a fun first party for America. That feels very, oh, and there's the pro-administration party as well. So Richard Bassett right here. Now, you'll notice that this is a table, but that right there is a hyperlink. The Richard Bassett there is a link through to another page. And this is using a SQLite feature of foreign keys, which are defined in this. When you create a table, you can say that a column references another column on another table. Dataset notices that, and it turns those things into hyperlinks. So this is getting into the sort of relational part of relational databases where data can link through to other data. Let's see if we sort the other way. I'm trying to find a legislator who's a bit more interesting. Wow, these are all one-term legislators. Here we go. So this one here, Jake Alesi, is actually referenced from two other tables. They're referenced from legislator terms, and they're also referenced from a social media table, because we've got a table of data here that tells us what their Twitter account is. But this is a very important concept in databases in general, and in datasets specifically, the idea to link these records together so that you end up with more of a sort of graph of data that you can start traversing between and really understanding how these things are all related to each other. My absolute favorite feature of Dataset is something called faceting. And that's the ability to spot columns like the type column and the state column and say, you know what? Of these we've got 44,000 rows here, but it's kind of interesting to count them based on the value in a specific column. So if we look at state, we'll see that New York has had 4,189 of these legislative terms, and is presumably because it's one of the oldest states. It's the state that's had the well, also it's going to be the number of Congress people that they get for their state, isn't it? We can look at like representative versus senator. So then I can drill down and say, you know what? Just show me the senators from Massachusetts, and then I can say, you know what, let's facet by party as well, and see that the state of Massachusetts in the Senate has had 38 terms served by Republicans, 32 by Democrats, 11 by Whigs. That pro-administration party from earlier on shows up. But the key thing about this is that when you're faced with 44,000 rows of data, it can be kind of difficult to know what to do next. You know, okay, great, I've got 44,000 rows. My favorite thing to do with it is to start digging into it using these facets and saying, okay, well, what can we learn about the data at the macro level based on slicing and dicing it in different ways? That's exactly what I've done here. I've just found out something about the state of Massachusetts Senate population based on clicking a few different links. You'll notice there's this interface at the top here is pretty much exactly what you would expect it to be. This is a query building interface. So you can select a column like state and say you want it where state equals MA, where type equals sen. And you know what, I'm going to say where, is there a name in here? I'm going to say where party contains, let's do rep. And that's given us back party, the Republican Party, the Democratic Republican Party, the Independent Republican Democrat Party, and the Liberal Republican Party as well. So you can use this interface to build up pretty complicated filters onto your data. Does it, what, say? Yes, it runs the full query. So if you scroll down, it's showing you all of the rows that match those criteria. And then if it was on multiple pages, which this one isn't, so let's get rid of that. The query builder. No. It doesn't. It would be useful if it could auto-complete things. That's not a feature that I've figured out yet. Here's where things get really fun. You can export this data back out again in multiple different formats. So if you want a CSV file of the Republican Party candidates from the state of Massachusetts, you can click CSV, and there's that data as CSV ready to be loaded into Excel or Tableau or things like that. You can also get it back out as JSON. So this right here is that data that we were just looking at as and in fact, I think if I do raw data and then pretty print, you can see this is JSON data here, which is specifically set up so that you can pull it into like JavaScript or Python applications running elsewhere. So you've effectively, this interface here is actually an API. And in fact, everything in Dataset works like that. If you can see it in Dataset, you can get it out as JSON as well. And so when you start looking at the URL, you realize that, okay, now we've got an API where we can specify in that URL that we want people from California, for example. And so now if I'm hitting that from JSON, I've got an API here where I can say, you know what, instead of California, let's do Florida. And now I'm getting things back from Florida. So this is effectively a very powerful API interface onto anything that you can fit in a SQLite database, which, as we discussed earlier, is everything. There was nothing that you could not stick in the SQLite database, put up online with this interface on top, and then start doing API automations against it. So we've talked about facets, and we've talked about filters.
So you said that we can apply this for any database. So how do you connect database to this?
So at the moment, the only way to get data into dataset is to have it as a SQLite database. So if your data's in some other form, you'll need to write tools to get it into SQLite. If it's in Postgres or MySQL, you'll have to export it out as a SQLite database file. I've been experimenting with ways of getting dataset to talk to other databases directly. There's actually someone in the dataset community built a DuckDB plugin, which monkey patched it around so that you could run it against DuckDB as well. I haven't committed to this as a feature yet because building software that speaks to multiple databases slows you down a lot, you know, in terms of you have to test it against all of the databases and write features twice and so forth. But I'm thinking it might happen maybe for dataset 2.0, which I hope to work on in the next sort of 12 to 18 months.
If a database has a lot of tables and you need to like join them or something, you don't need to like do that manually. You'll have like a list of tables and fields, and then you just say, I want this, and that.
Yeah, well,
Will join and just give you final.
we'll get into that in a little bit. For more advanced stuff, you actually end up writing your own SQL queries directly in the dataset interface. And I'll jump into, we can jump into that right now. This is quite a good point for that. So right here, we're looking at 954 rows where the party contains rep and the state equals CA. And if I click View and Edit SQL down here, it will switch me into an interface where I can see that underlying SQL query. Let's click Format SQL to tidy that up a little bit as well. So now it's exactly the same data coming back, but we're now in a situation where we can start editing that SQL query. And so I can actually make changes to it. I can say, you know what, I don't care about those columns or that one or those. I just want those ones right here. And click Run. And now I get back that subset of columns that I've defined in that SQL query. And I can then say, you know what, let's do, instead of rep, we'll do dem. The percentage symbols there are because we're using a like operator, and the like operator does wildcard matching. So here we're saying wildcard match where the party column contains any number of characters, DEM, any other number of characters at the end. Why are these in? That's because end, I believe, is a reserved word in SQLite. So if you take the square brackets, okay. I was expecting that to break. I think there are definitely, I think if the column was called select, it would definitely break. So dataset plays it cautious, and if it thinks something's a reserved word, it escapes it. And actually, you can escape it using double quotes, or you can escape it using square brackets. I've been a bit inconsistent in using both of them. I should probably just stick to the double quotes in that case. Yes, which is just messy. That's unnecessary. In this particular case, I could get rid of these and it would work just fine. So that there is because this is the named parameter trick that we used earlier on with the insert query. What we're saying here is that I want party to be like something called P0, and I can actually change that to be party. And I want state to be like :state. And dataset then notices that those are there, and it adds them as form fields at the bottom. So a trick that you can do with this, which is kind of fun, is that this actually becomes a way of building little custom applications for people. There's a hide button at the top that hides the SQL query. And so now, if you've got a friend who desperately wants to be able to look at, and let's get rid of this one here, let's say just where state equals state. So if you have a friend who desperately wants lists of legislators from the state of from any state they like, you can send them this bookmark, like literally copy and paste that URL, send it to somebody else, and when they land on it, they'll get this page here with a form field where they can change CA to FL to run the query again. I kind of think of this as a way of building entire interactive database applications as a bookmark. And so it's something you can share on Slack, or you can send to somebody a message or email. And it's a really fun and powerful way of working with data, especially in a collaborative environment. Dataset, the initial inspiration for this was data journalism. I was working for newspapers where we were dealing with all kinds of weird and interesting shapes of data. And you want to make that available to the reporters in the newspaper so that they can look at the latest COVID figures or look up what some senator has been doing, things like that. And so the idea here was to have a few people in the newsroom who know enough to load data into this system and sort of construct these SQL queries. And then everyone else just works off of bookmarks. If somebody says, hey, have you got the latest COVID numbers for New York, you can send them a link, and when they click that link, they will get that data come back at them in this format. As before, as with the table view, you can get the stuff out as CSV, and you can also get the stuff out as JSON. So what we've got here, which is kind of fascinating, is we've got we have an API. Where's the wrap option? Hang on. I have totally messed that up, haven't I? Here we go. This right here is a JSON API that takes an argument of SQL equals and then takes a SQL query. So effectively, we've built a JSON API that a JavaScript application can use to run SQL queries directly against a database, which, oh, that's fun. Copilot's trying to suggest what, wow. GitHub Copilot just guessed that the response of that would be the Federalist Party in Florida. That's quite a surprising completion it pulled off there. But yeah, so we've built an API that you can send SQL through, which for most developers will tell you that this sounds like an appallingly bad idea. There's in web application security, there's a concept of a SQL injection vulnerability where people can use tricks to run their own SQL against your database. And normally you don't want that at all. But Dataset was specifically designed for a world in which you're publishing entire databases. So you don't mind if people can query any of it, because that was the whole point. You wanted to put that data out there. And everything, the SQL queries are run against read-only databases. They can't cause any damage to them. And there's also a 1-second time limit that's enforced on those queries, which means that despite this being a wildly sort of unexpected thing to do, having an endpoint that people can just run their own SQL queries against is both safe and really flexible. I built some applications when I worked at Eventbrite a few years ago. I built an application that used this in JavaScript basically as a joke. I was trying to wind up the other developers at the company by saying, hey, look, I use JavaScript to glue together a SQL query. Only it turned out it was just a really productive way of working, especially for rapid prototyping. So I've ended up building all sorts of software on top of this since then. And I'll show you a much more advanced example of that in a moment. But yeah, so that's the sort of core of the Dataset web application. It's got tables in it. You can browse those tables. You can filter them and facet them and explore them in that way. You can get the data back out as JSON or CSV. And actually, this one here is running a plugin called Copyable, which lets you get the data back in all sorts of other formats too. If you're writing an academic paper and you need a LaTeX table of all of the Florida representatives since 1821, you can click that. You can click the LaTeX button and copy and paste this right back out again. Actually, I use the GitHub one here all the time because it lets you get things out as a markdown table that's formatted for GitHub issues. But let's jump back to the demo that I was running just off my own machine. And I'm going to demonstrate plugins a little bit more. Hang on a second. What's happening there? My Control-C shortcut isn't working. Okay, I killed that. I'm going to say, oh, it's because I switched out of Dvorak mode. That's why that wasn't working. So I'm going to say dataset install. And I'm going to install a new plugin called dataset-cluster map. So Dataset is very, very heavily reliant on plugins. There are 115 plugins available at the moment in the Dataset plugin directory. And as an open source maintainer, one of the things I love about this is that people can add new features to my software without me even having to talk to them or even review a pull request. I can wake up in the morning and somebody has shipped a new Dataset plugin that adds some kind of feature, and I had nothing to do with it at all, which is so liberating in terms of me getting to see my software expand out in interesting ways. A lot of the work I do around Dataset is writing plugins myself, because the beautiful thing about plugin is that if it's rubbish, it doesn't harm the sort of purity of the core project. I can have a weird idea for a feature, knock out a very quick sort of poorly constructed plugin to try it out, and then sort of iterate on that over time and figure out if that's what I really wanted to do. Dataset Cluster Map is one of the, I think it might even be the very first plugin that I ever wrote. And you can install it by saying dataset install dataset cluster map. That's actually the same thing as running pip install dataset cluster map. The reason I have a dataset install command is it makes absolutely sure that the plugin gets installed in the same virtual environment as dataset itself. So if you install dataset through Homebrew or pipx, it'll go in the right place and you won't have to think about how to install it. So I'll run that plugin, run that installer. I can type dataset plugins to see a list of available plugins. And this says I've got dataset x forwarded host, leaflet code spaces, and dataset cluster map is the one that I just installed. Now, if I run dataset legislators again, what this plugin does is it looks out for any table that has a latitude and longitude column on it, and if it finds one of those, it draws them on a map. And so in this case, the offices table, this is the congressional offices of all of these different legislators, has latitude and longitude. And so the plugin kicks in and it draws this map at the very top of the page. And again, straight away we see some interesting things. What's this one here? This is in Pago Pago. Is this American Samoa, maybe? This is one of those far out tiny sort of bits of the United States. But there's a congressional office there, so instantly that pops right up. You can see that Hawaii's got 3, all of them in Honolulu, it looks like. And was it Puerto Rico is the other one over here? Oh, no, that's not Puerto Rico. That's the US Virgin Islands. One of the fun things about playing with these tools is I always learn new things about the world just through little things that pop up while I'm doing demos. But yeah, so I think it's a good example of the thing I'm trying to get to with these plugins. Like my ideal for plugins is that they'll grow more and more abilities like this one, where they can look at your data and say, oh, that's interesting. This appears to be mentioning countries. I could draw a heat map, or this is latitudes and longitudes, or all sorts of things like that. And I think there's a lot of scope for really interesting data exploration features that are built around this idea of plugins that you can run in Dataset that then get exposed to your data. We talked about exporting data. It's also worth noting that you can export the current page of data that you're looking at. So if I'm looking at legislator terms, I can get out, I think it's 100 records at a time. Or if you scroll to the bottom of the page, you can click Stream All Rows on the CSV export, and this will actually generate a CSV file with everything, with all 45,000 rows in it. And I just clicked on that. I think it's going to open in numbers. Here we go. So now I've exported the full 44,551 rows from that table in a format where I can load it into any other tool that knows how to open a CSV file. Oh, yes. No, yeah, that's a good call. It's worth us talking about primary keys in SQLite. So when you create a SQLite table, you can give it a primary key. So you can say, this one's got an integer primary key, for example. But I think some of these, this one here does not have a primary key at all. Right? It's got a register ID, type text, etc., but it's missing that primary key. And this is a SQLite-specific feature where if you don't specify a primary key, SQLite will add one called row ID that's essentially it's an automatically incrementing number. So this is kind of convenient when you're just sort of quickly importing data. You don't have to think about if it's got a primary key or not. You can import it in, and SQLite will automatically assign a unique identifier climbing from 1 and going up, and make it available as that row ID. And when you do select star, I think select star will not give you the row IDs, but if you do select row ID comma star, then you can see that column. So it's a bit of a weird column in that it's hidden from select star, but if you know about it and you know to call it, you can get it back in. And Dataset knows about this row ID thing, and so it will automatically include the row ID in situations where there isn't a defined primary key. Now, we sort of touched a little bit on that on the next sort of tutorial segment, which is the idea that the dataset is actually a really useful tool for learning SQL itself. And this is one of the reasons I don't plan to spend a great amount of time on sort of SQL fundamentals today, is that a lot of the stuff that you need to do with SQL, you need to know about creating tables, inserting, updating data, and then you need to be able to start running select queries. But Dataset will do a lot of that work for you, right? It will let you say, you know what, I want everything where this and this and this, and then clicking on that View and Edit SQL button will get you into an interface where you can see how that SQL query was working. So, and I've heard from there's a couple of universities that I've heard from who are now using this as part of their sort of database education, because it's just a really quick way for the students to start exploring data and getting a feel for what relational databases feel like, and then starting to dip into SQL as and when they want to get the hang of that. So we'll talk about some advanced SQL tricks in a little bit, but for basic SQL, you can get a very long way just noodling around in Dataset with the filters and then seeing what query that generated. So I think this tutorial here, this is the Learn SQL with Dataset tutorial. This goes into a little bit more detail. So this will talk about select, from, where, order by, and limit, the sort of key areas of a SQL query. And there's a bit of material here as well about the named parameters that we talked about, where you can say, you know, where start like :P0 and type equals :P1, and then feed those in as separate fields. And there's a little bit about SQL-like queries and joins in here as well. You know, I think we probably should talk about joins in a little bit more detail, because that's something we're going to see again later on. Is anyone here super happy and comfortable with joins and left joins and right joins things all the time? I'm not putting my hand up either, because I still have to look things. I'll be honest, I don't think I've ever used a right join in my entire career, and SQLite itself only grew right join support 6 months ago, maybe, because everything you can do with a right join, you can do with a left join, and so on and so forth. But we'll review the most basic kind of join, just to make sure that we've seen what one of these looks like. And the problem that we want to solve here is that we've got this table of executive terms. So this is saying that there was the president from 1789 to 1793 was from this party, and it was executive ID equals 1. That right there is a reference to another table. So I can say select star from executives where ID equals 1, and see that that means George Washington. So we've got a reference to George Washington in this table, and we've got details about George Washington here, but it would kind of be nicer if we could see the name George Washington in the table that we're looking at right there. That's a great call. This right here is not an assignment. It would be nicer if it was equals equals. Exactly, yeah. This, in Python terms, this is select star from executives where ID equals 1. Unfortunately, SQL is not designed like that. So SQL confuses equals as assignment with equals as comparison. You could actually, yeah. So I could say where that equals :ID, and then I could stick a 1 in here, and that'll have the same effect. So we want to see George Washington's name on this table right here. And the way we're going to do that is we're going to do a join. So I'll copy and paste this query in here so we can explore it. So first we'll run that, and you'll see that now we've got the same data we had before, but instead of executive ID, we have a name, and the name is that information pulled in from that other table. Maybe we could do select star instead and see if that's... So if I do select star, I now get back everything from both tables. So I'm seeing the executive terms columns that we saw earlier, and then I'm seeing all of that stuff from the executives table. And the way this works is through what's called a join. I can say, where we're selecting from the executive terms table, and we're joining against the executives table on executiveterms.executiveID equals executives.id. This is the structure of a join. You say, this table and this table are going to get combined together, and the way we're going to do it is on this criteria, the on criteria, saying anything where the ID in executives matches the executive ID in executive terms. These, you can actually you can do multiple joins against multiple tables. There's a lot more sophistication to this, but most of the time I find that I'm using the most basic kind of join. This, I think this is called an inner join, or I just call it a join. But it gives us what we want, right? This gives us the ability to start saying, let's combine party and then executives.name. And when you're constructing queries like this, you can leave the tables off in this bit here, but then it gets kind of confusing because when I look at this, it's kind of like an import star in Python. I don't instantly know which table these different things came from. So personally, I like to always include the full table names. So I'll do that, dot that, dot that, dot that, dot that, and then executives.name there. And that gives us the exact same results. It's just easier to read that query and understand how it works and what it's doing. That's surprising. I don't know why my format button is getting confused by end being a reserved word. But yeah, so that's honestly this. I recommend if you want to spend, if you're not familiar with SQL, I recommend spending a little bit more time with this document. But as you can see, it's relatively straightforward, and we'll get into the more advanced SQL stuff in a little bit. But it's a pretty clean language to start working with. Something I really like about SQL is that when I started learning to be a programmer nearly 25 years ago now, I learned Perl and PHP and SQL and ActionScript, all sorts of different bits and pieces. SQL is the one thing I learned 25 years ago that's still serving me today. I feel like it's one of those skills which, kind of like Bash on Linux, pick it up once and it will be paying for itself for decades to come. So, and I mean, as somebody who writes software around SQL, I have some bias here, but I do think it's worth spending time with SQL and getting to a point where you're really comfortable and familiar with it, because it will apply to SQLite, but also so many other technologies as well you can then tap into. And the syntax for basic select statements is effectively the same across all of the different database engines. Let's get into something else. Let's start to... So I've shown you a bunch of stuff so far that assumes that you've got data in SQLite already. If your data's in SQLite, then you can run dataset against it, and you can do all of these things, and that's super fun. But obviously, the vast majority of data in the world is currently not in SQLite, which is something that I'm on a one-man quest to try and fix. But so the other major project I've been working on for the past 2 years is a tool called SQLite Utils. It's this tool here. It's up to version 3.30, so you can see I've shipped a lot of changes and fixes to this over the years. And SQLite Utils is two things in one. It's a command line interface, it's a CLI tool, and it's a Python library for manipulating SQLite databases. The specific problem I'm trying to solve with it is, what is the fastest way to get from here's some data to now that data's in SQLite and I can start running queries against it. And so you install it exactly the same way as dataset. It's a pip install or pipx or brew or various other things like that. I'm going to do that in here. Actually, let's fire up another shell again. Here we go. Export. PS. I need to figure out how to set this up as the default. There we go. Okay, so I'm going to do pip install SQLite utils. And this will give me a Python library that I can import, but it also gives me a new command called SQLite-utils. Run version on that. There we go, I've got version 3.30 of that installed now. And what we're going to use this to create ourselves a brand new database from a new data source. This is following another of the official dataset tutorials. We're going to take a look at data about manatees in Florida, and specifically where manatees have come a cropper, manatee carcass recovery locations. So this is data put out by the Florida Fish and Wildlife Conservation Commission, and they have been collecting information on where dead manatees have shown up since April of 1974. So there's 50 years of manatee carcass locations represented in this CSV file. And it's got 14,341 records in it. It's available as CSV. I've actually got a copy of that I archived just in case they change their file format, which we can download from here. So I'm going to right-click on this, copy link, and then back in here, I'm going to do wget of that. And so this has given me the file manatee carcass recovery locations in florida.csv. It's a 2.7 megabyte file. Next, I'm going to load that into a SQLite database using the SQLite-utils tool. So, I wonder if there's a way I can pin this so it's easier to find. So I'm going to run a command, SQLite-utils insert, because we're inserting data. I'm going to create a new database file called manatees.db. I'm going to create a table called locations. I'm feeding it the path to that file, and then at the end I'm saying this is CSV data, and then -d means try and figure out the types of that data. So if a column looks like it's all integers, treat that as an integer column. If you don't do that, you'll get everything as strings, which isn't quite as useful. Nulls. So this is the problem with CSV, is that a null and a blank string are completely indistinguishable. So SQLite-utils will always import them as blank strings. If you want to then turn them into nulls later, you have to do that yourself. This is one of the reasons I prefer JSON over CSV as a way of passing this data around, because JSON does have nulls. It has nulls. A floating point number in JSON is represented as a floating point number. It's generally, I think, better. But most of the data in the world is published as CSV, so we have to have tooling for working with that. So we now have a file called manatees.db. It's 5.4 megabytes, and I'm going to open that up in Dataset as well. Yes, so that's in this tutorial here. It's SQLite-utils insert manatees.db locations. So that's the command, the database file, the table. This is the name of the CSV file. And then at the end, I'm saying treat this as a CSV file and do the type detection as well.
You can find that page in the read logs. So if you learn SQL, dataset, you find that page and you can find it.
Excuse me, is there a user-friendly interface for SQLite, or you can write everything in the command line?
That's a great question. Is there a user-friendly interface for SQLite? So, are you stuck in the command line? There are many. One of the great things about SQLite is it's been around for 20 years, and so there are Windows apps and Mac apps and GUI apps, and there are dataset plugins that actually add the ability to upload CSV files directly into Dataset as well. So there's lots and lots of different options for this. I tend to do most of my analysis most of my data manipulation on the command line because I like that I can automate it. So I can figure out a recipe that works for manipulating data in a certain way, and then I can stick that in a bash script, or a lot of the work I do, and I'll show some examples of this later on, is in GitHub Actions. So I have GitHub Actions automations that download data from here and then convert it and then do this and clean it up and all of that kind of stuff. But yeah, for the so SQLite-utils, you can actually use in a Jupyter Notebook as well, which I'll demonstrate in a moment. But there's an aspect of this where I'm enjoying the intellectual challenge of coming up with a command line interface version of every Python method that I'm writing. So a lot of this is me just having fun trying to explore the intersection of command line tools and Python libraries. Let's run a different command actually. We're going to do SQLite-utils. SQLite utils schema manatees.db, and that dumps out the schema, so we can see the schema of that database that we just created. And actually looking at that schema is kind of interesting, because you see things like there's an X and a Y column that are floating point. There's a lat and a long column that are floating point as well. So we've got potentially 4 different ways of representing those locations. But it's better to fire it up in dataset itself. So here is that table that we just imported. It's got 13,000 rows in it. And it's a table, and as with all tables, it's kind of boring when you first start looking at it. You know, it's got these X and Y columns, the year that they were found, the state, the county, mortality. This is an interesting one. We can facet by that and see the most common reasons that a manatee meets their end. And unsurprisingly, it's watercraft collisions. That's taken 2,700 manatees in the state of Florida. Cold stress, beginning in 1986, 1,233. And then floodgates and canal locks have killed 254 manatees. So that's something you should watch out for if you're a manatee. But what we're going to do now is we're going to make some changes to this data, because that schema is a little bit untidy as a sort of starting point. Actually, I'll show one quick other thing that you can do. So with SQLite utils, you can run SQL queries. Here I'm saying SQLite utils against manatees.db. I want to select those columns, and out it comes. And actually, I think I need to, there we go. If I drop the font size down, you can see that that came out as a tab-separated table. I think if I, instead of -t, by default, without any options, it'll output JSON, which is useful for piping into the commands. You can also say --format, and then I think it might even let me format it. There we go. This is LaTeX on the command line, should that be a thing that is useful for you. So there's a lot of stuff you can do with SQLite utils just as a command line tool for querying data. But let's make some changes. So when we were looking at this table earlier, it became apparent that, where has it gone? Where have our manatees gone? So some of these columns are kind of pointless, like field ID doesn't look very interesting. The rep month and rep day is already represented in the date. Every single one of them was last edited by user FWC, so we don't really need those columns since they're all the same values. So we're going to run this column here. This is this command here. This is the transform command, and what this can do is apply a whole bunch of alterations to the table that you specify. It's effectively a very fancy alter table statement. And this is actually making up for a limitation of SQLite itself. Databases have a query you can run for alter table that can make changes to a table. The SQLite one's actually quite limited. There are things that it can't do. It can't reassign the primary key. It used to not be able to rename columns, but I think they might have fixed that. So this command here does a whole bunch of wild things under the hood to make more complicated alter statements available to you. The way it actually works is when you run this, it will create a brand new table called locations temp in the new format. It'll copy the old data to the new table. It'll drop the old table and then rename the new one back to the old one. So there's a lot of activity hidden by that command. But the end result of this command is that you can make all of the alterations to your table that you want to. So we're going to do a few things. We're going to rename the lat column to latitude, and rename that long underscore column to longitude. That's so that our cluster map plugin can pick up those columns and show them on a map. We're going to drop those created user, last user, XY, state. We're dropping the state column because it's all in Florida. We don't need to know which state it is. We'll drop object ID, and we're going to reassign the primary key to be this field ID column as well. So that's a lot of stuff that's going to happen. And if I run that right now, here we go. Oops, terminal. It's done. So that should have changed all of those different things that we wanted to change. So now if I refresh this page here, there we go. We've now got a map because we've got latitude and longitude columns. We've dropped a whole bunch of those columns that we didn't need. And having that map, and we can actually, the map defaults showing 1,000 points. You can actually load all 14,000 points on. So now this is a map of every single time a manatee carcass has been discovered in the state of Florida since 1974. And, oh, that's interesting. I wonder what happened to, not many manatees died around there. That poor manatee got very unlucky. Also, it's nice to note that the Florida Keys look a lot safer than the rest of Florida. There seems to be a lot less manatee deaths down there than up around the edges. So again, this is a classic demonstration of how you start with a CSV file, you run a couple of commands, and now you can tell stories. You can start understanding that data in much more detail than if you were just squinting at it in Microsoft Excel. There is one more change that we want to make to this. So we've visualized the locations. The date columns. So I'm European, and I think that the way Americans do dates is completely, the whole month, day, year thing is not good. At least in this case, the dates are slightly better. This is year, month, day, which is closer to my European sensibilities. But it's not quite the format that I like. And so another command that SQLite utils has is called SQLite utils convert. And this can be run to convert the values in one or more columns to some other format. And I'm going to run that right now. There we go. This one actually shows you a little progress bar as it whizzes through. And having run that, if we refresh this table here, there we go. This is much more pleasing to my eyes. We're now in ISO formatted dates for all of that data there. You'll notice that the command I ran there actually has a little snippet of code in it. I'm saying convert the manatees, look at the locations table, look at data in these three columns, so the rep date, created date, and last edited date columns. And for each of those, I want you to run this little Python expression. And this is actually a snippet of Python. You can put any Python expression you like in there. In this case, I'm using a baked-in function called parseDateTime, which is using, I think it's using date util under the hood, but it basically, you can give it any string you like, and it will try and convert that into an ISO formatted string. So this is a really powerful way of rewriting data on the fly. I often find myself starting with a CSV file, I import it, I spot that some of the values need to be converted to lowercase or have their dates processed or whatever, and I can do all of that as these command line invocations of that SQLite utils command. So R stands for, it's a namespace, and I can't remember why I called it R. Let's have a quick look. I think you're right. Yes, it's recipes. Yep. Command line tool. It's the converting data from columns. Yes. Yep, it was R for recipes. So there are a bunch of other recipes that are available on that object. There's like a JSON split one that splits comma-separated values into a JSON array, parse time. Oh, that's it. There's three built-in recipes that you can use. And then most of the time, I will use little Python expressions like this, like value.upper will convert things to uppercase. Float value plus 0.5 will convert it to a floating point number and add 0.5 on the end. SQLite utils has extremely extensive documentation, both for the Python library and the command line tools. So there's a lot of stuff that I'm not going to, there's a huge amount of stuff that I'm not going to cover that it does today. Right, so yeah, the question is, how do you decide when to use Python and when to use SQL? SQLite, its SQL is very limited. Like SQLite can do string concatenations and adding numbers together, but it can't even do like it can't do math operations beyond like multiplying and addition and such like. It's missing more advanced string manipulations aren't in there. If you're used to Postgres has a very rich SQL language that can do regular expression extractions, and just almost any string operation you want is built into Postgres. That's not the case with SQLite. And so but what SQLite does let you do is it lets you register Python functions with names in SQLite so that they can be called as SQL functions. And Dataset does that quite often. SQLite utils can do that as well. And when you use SQLite utils in this way, when you give it that that conversion function, it actually defines a new Python function called convert. It registers that. It runs the SQL query of update table set something equals convert bracket something else. And that's how it all works. So your Python code is being executed effectively inside of SQLite as a custom function. That's how the internals of the system work anyway. There's actually other stuff you can do with SQLite utils too for registering functions. Yeah, you can do things like this. You can say, that gets to the right place. SQLite, when you run a query, one of the things you can pass is you can pass -- functions and actually pass it a block of Python code that defines some additional Python functions, and those will then become available to your SQLite query. So that's a sort of advanced feature that I wasn't going to go in today. But if you want to use Python functions as part of SQL, it's got you covered. That's a feature that's available in the library too. That's kind of fun. Okay, we're going to do one more operation on our manatees database, and that's that when we take a look at our manatees, one of the things we notice is that this data is not particularly. After this, we're probably going to do a break. Okay, great. Yeah, so this mortality column is duplicate data, right? It's the same string, verified not necropsied, repeated thousands and thousands of times. In database design, this is bad, right? This is, if you ever hear people talking about database normalization, one of the things that means is that you don't duplicate the same string thousands of times just because that's the way the data came in. Another thing you'll notice is that there's mortality and there's a thing called decode. And if we facet by both of those, so facet by decode and then facet by mortality, those numbers are exactly the same because it turns out decode of 1 means human-related water curve condition, 4 means perinatal, 8 means that. These are duplicate data. Right? We've got the decode and we've got the mortality, and we really shouldn't need both of those. So what I'm going to do is I'm going to extract that. I'm going to create myself a new table that's just those mortality codes, and I'm going to rewrite my existing table to reference that one instead. I think what I'll do is I'll demonstrate that first, and then we will, let's go back up to here. So our manatees database currently has a single table called locations. I'm going to run this command here, SQLite utils extract. I'm extracting from the manatees database from the locations table. I'm saying pull out the decode and the mortality, rename mortality to just name, and put them in a table called mortality. So I run that, and now when I hit refresh here, I've got two tables. I've got my locations table, and I've got a new table called mortality. If I go in here, I can see that those are all of those unique values that we had a moment ago. And if I pop back into the locations table, I no longer have those columns. I've now got a new column called mortality_ID, and that's one of these foreign keys. That's now a foreign key reference to this new table. We can scroll down to the bottom and see that the table is now defined in terms of mortality ID is an integer. There's a foreign key of mortality ID referencing that other table. So SQLite utils has pulled that data out, created a new table, populated that table, rewritten this table to have a reference to it. It's done, again, a lot of work under the hood to get you to a point where now we've got a database that is a table that is much more normalized. Like we're no longer duplicating that data. We've got a foreign key reference that we can follow. Features like faceting still work. You can say facet by, in this case, mortality ID. Oops. And when you do that, it's dataset's smart enough to pull in the official name of that. But that's kind of, this is, as somebody who works with databases a lot, I haven't actually seen this particular kind of refactoring tool for anything else. And I find that I use this with my SQLite databases all the time. I'll start with manatee carcass locations, and then with just a few additional steps, I can get to the point where I've actually got a clean relational, I've got a relational schema for that, multiple tables, like foreign keys, all of those bits and pieces are all set up and working together. So yeah, there's a whole bunch of other stuff you can do with SQLite utils. This documentation here links to like additional information about those conversion functions and refactoring and all of that sort of stuff. But hopefully this gives you a good feel for what you can start doing with that as a command line tool for manipulating that data. That's a great question. So the question is, if you've got two CSV files, can you foreign key from one to another? Yes, you can. I don't have a good demo for that right now, but the way you would do that is you'd import the two, and then there's a command in here called adding foreign key constraints. So you can basically say, SQLite utils add foreign key on my books.db database to the books table, tell it that the author ID column is a foreign key to the authors table and the ID column. So it's a bit of a mouthful, but it can do that. And that's another example of something which SQLite out of the box doesn't have the ability to do. You actually have to do some very weird things to the SQLite metadata to get that to work. But SQLite utils has all of those patterns baked in. So yeah, one of the capabilities it gives you is the ability to add foreign keys to tables that don't have them yet but should. So we are almost exactly halfway through. I think we take a 10-minute break now, and then when we get back, we're going to dive into some of the more advanced. Well, firstly, we're going to create a database of PEPs and publish that to the internet, and then we'll start diving into some advanced SQL as well. But yeah, let's reconvene it at 3:05. Okay, we'll kick off again in just a moment. We are going to be on this section here, the using SQLite utils as a Python library to import all of the PEPs. So it should be linked to, okay, it's linked to from the index page of the tutorial workshop. Okay, so actually what I'm going to do now is I'm going to switch to a Jupyter notebook. And again, this is one of the things I like about CodeSpace, is it makes it nice and easy to do this. I'm going to go in Notebooks, right-click, New File. I'm going to call it SQLite.ipynb. And this takes a little while to start running because it has to detect kernels and things like that. Select kernel. I want a Python environment. I want Python 3.10. Okay. There we go. That's worked. Great. So the next thing I'm going to do is I'm going to use the Python library version of SQLite utils. Everything that you saw in the command line tool do earlier, you could also do by importing SQLite utils into Python and doing things there. So I'm going to import SQLite utils and then do db equals SQLite utils.database. I'm going to create a database called peps.db. Okay, here we go. This is our PEPs database. If I say db.tables, it shows me an empty list because there aren't any tables yet. And I'm actually going to create a database of all 400 plus PEPs. The easiest way to get that data is that you can git clone it. So I'm going to do git clone of the Python/PEPs repo, and I'm going to put it in /temp/PEPs. This is a habit I have for all sorts of things. I'm very lazy about deleting files, so anytime I don't think I'm going to want to keep something, I stick it in my temp directory, so next time I reboot my computer, I don't have to worry about it anymore. So I'm going to run that. I'm running it in a Jupyter Notebook cell, so I put an exclamation mark at the beginning. There we go, cloned into /temp/PEPs. And there they are. That's all of those PEP files. So now what I'm going to do is I'm going to grab that. Remember that code we wrote earlier, the parse PEP function that can turn a PEP into a dictionary. So I've got that. And now I'm going to use pathlib to get a list of all of the files in that PEPs checkout that match the file pattern pep-star.txt. So I'll do that. And now, if we look at files, len files, comma, files, colon, 5. There we go. So we've now got 429 PEPs as files on disk, and each of those files looks something like that.
Is this code?
Yes, so the code for this is all in the handout for the workshop here. And now I'm going to pass them. So I'm going to loop through every file, and for each one, I'm going to call pass pep on the text contents of that file and stick it in a list. So we'll do this. And now, if I look at len of peps is 429, and each of those peps is a dictionary, and it's got a pep ID and a title and a version, or author status, all of those different fields that came out of those text files. So now we want to turn this into a SQLite database. So we can do import SQL. Oh, we actually did this already, right? We did. I'll run it again. So import SQLite utils. Then I can do db equals SQLite utils database peps.db. And now I'm going to insert them. So I can say db square brackets peps. This is a shortcut for getting a reference to a table in that database. SQLite utils will, if the table doesn't already exist, it will create it. So I can say that dot insert all peps. And then we know that we've got a primary key, which is the PEP column. So I'm going to tell it to insert all 420 of those peps into a new table called peps and give it a primary key. And this failed with an error. The error was table peps has no column named pep delegate. So what's happened here is that we've got a list of dictionaries, and it creates a table to match the first dictionary and then tries to insert all of the data. But it turns out later on in that list, there's a dictionary with an additional key in it, which breaks everything. So we're going to drop our table, and we're going to try this again. So let's do db peps.drop to get rid of it. And now I'm going to add alter equals true. And alter equals true means when you're inserting this, if you find a new column that you haven't seen before, alter the table to add that column. So running this, that worked. I've now got a peps table. I can run dbpeps.schema, I think with a print, to see what there we go. That's the column, that's the table that we've just created. And if I switch back over to dataset, where's dataset? It should be in the terminal. I'm going to stop dataset, and I'm going to start it again and add peps.db to it. And now, if we go back to here, oh, what happened there? Service unavailable. Is it crashed, or is it just taking a while to start up? Oh, path peps.db does not exist. That's because it's actually in the notebooks folder. There we go. All right, now we've got our peps. And so this right here is the database table that we just created. It's called peps. It's got all of the columns that we wanted. You'll see that it's actually got a bunch of weird columns towards the end, like BDFL delegate is apparently a column in one of these things. We've got the pep ID as that primary key. So if I want to go and find pep20, I can say where pep equals 20. And there it is. There's the Zen of Python in our SQLite database. I can get it out as JSON. I can get it out as CSV. All of those features we had before are available. But crucially, creating this table, all we did was effectively this one-liner. We said, create a table called peps, insert these things, set the primary key, add any columns that you need to add. That's the whole thing. That's done. So most of I showed you work that I do with the command line tools earlier on. Anytime I'm doing anything more sophisticated, I do it in a Jupyter Notebook. I import SQLite utils, I fire up a Jupyter Notebook, and I use exactly this workflow I'm showing you here, where you grab files from Git, or you download JSON over HTTP or anything like that, and just start splatting things into these, almost treating the database itself like a dictionary, where each of the keys in the dictionaries will end up being a table. This is an amazingly productive way of working with data, because normally when I'm working with a relational database, I spend 90% of my time sweating over the schema. I'm like, okay, I need to know what columns I've got in advance and what types I should have in those columns, and think about the primary keys and all of that. And here, I'm skipping everything in terms of database design and just saying, I've got an array of dictionaries, make a table. And it makes a table, it derives the correct schema. All of that sort of tedious database creation work is done for me. And now I've got again, I've got an API, right? This is now an API for PEPs where I can filter and search and do faceting. And actually, let's do some faceting now. So there's a thing called status, which out of our, 429 PEPs, 220 are final, 96 are rejected, 31 are deferred. There's a type column. I'm going to facet on that. Standards track informational process. There's a PEP that's an April Fool PEP, which you click on, and this joke hasn't aged very well. This is from April 2009. It's a joke announcement that Guido van Rossum was retiring. I think he actually did retire a few years after that, and then he came back again. But you know, this is preserved forever in the Python enhancement proposals GitHub repository. Yeah, so it's very, very little work to get from data in some shape or form to a database table that we can start doing all of the fun stuff that we've seen so far. Oh, that's a great question. So the question is, what do you do if you want to create a data frame from this? I will be honest, I don't use pandas habitually enough to just run that straight off the top of my head, but let's have a go. So if I do pip install pandas, I think pandas has a thing where you can do, what is it? Import pandas as PD dot. But you can actually do from SQL, can't you, in pandas? Well, there's a CSV thing, but isn't there a pandas?
Yeah, there's a pandas read from SQL.
That's it, read SQL. This is the one. This will do it. Okay, so I can say pandas dot read SQL brackets db.con. Oh no, it's the SQL first, isn't it? Select star from peps db.con. Yep. PD. Did that work? Yeah, there we go. So what I did there is the pandas read, the pd.readSQL method takes a SQL query and a SQLite database connection. Our DB object isn't a SQLite database connection, it's a special SQLite utils one. But db.con, which I don't know if is documented, I should make sure that's documented. db.con is that underlying SQLite query. So yeah, this is this is how you would get that same data into pandas. And you could do it otherwise as well. Pandas, you can give it a list of JSON objects and all of that kind of stuff. But I think this is probably the cleanest way to get from SQLite or SQLite utils into pandas. And it's kind of neat that we, again, we started with that list of objects. We round-tripped them through that SQLite database, and now we've got them in pandas again. So that's kind of cool. So this bit here talks about the arrow. So we're going to do one more trick here. Wouldn't it be neat if we had a proper search engine for our PEPs? Now, SQLite, one of the many, many features of SQLite is it actually has a really robust search engine built into the database. It's called the SQLite FTS5 extension, where FTS stands for full text search. And this is a shockingly capable piece of software. It's actually, there's an aspect where this is better than what Postgres gives you, because Postgres has a very good, it's got full text search baked in, but the Postgres full text search can only work based on the sort of information about individual rows. So it can give you, like, it can give you matches for a term, and it can use stop words and all of that kind of stuff. But Postgres doesn't have ranking built in. Like, when you're using a search engine like Elasticsearch or Lucene, the ranking algorithm takes into account the how common a term is in the whole corpus. And so if you search for something which is very rare overall, but is super common in a few rows, you'll get those rows back. SQLite actually has that baked in. It does full-blown BM25 search ranking, which, again, puts it a little bit above Postgres in terms of the sort of out-of-the-box search capabilities. But anyway, what we're going to do is we're going to set up a search engine. And I'm going to do it by saying db peps, that's our table, dot configure FTS for configure full text search. I'm going to make it searchable by the title and the body columns. So configure full text search, and we feed it a list of those columns. And if I run that, now if we run db.tables, actually let's do db.table names. Oh, hold on. That's surprising. There should be another table in there. What went wrong? Oh, I said configure FTS, didn't I? Or did I? I don't know. It should be .enable FTS. So, okay, I've run enable FTS. That took 0.3 seconds. If I look at the list of table names, here we go. So now we've got that PEPs table that we started with. And we also have 5 new tables relating to this full text search index that we've just created. You do not have to worry about the details of these tables at all. They're sort of effectively an implementation detail of how SQLite full text search works. But now in dataset, if we refresh this page, it spots them and it adds a search box. So this is a dataset feature. It knows about full text search in SQLite, and it knows how to tell if a table's got it set up, and it adds a search box to it. So now if we look for, say, generators, and run that search, there are 42 PEPs where the title or the body matches the search term generators. And that looks about right to me, right? We've got range literals. Something I'm going to do here is I'm going to hide the body column just to, because it's taking up a lot of space. So yeah, this looks spot on to me, right? Coroutines, generators, continuations, simple generators. We've just built a search engine on top of Python PEPs, and it was a single line of Python code to get that to happen. There is one missing feature here. You'll notice that this is showing us search results for generators sorted by that ID column. So 204, 205, 219, 220. It's a search engine. We kind of want to sort by relevance. Dataset doesn't have search by relevance as a built-in feature yet, and that's just because I haven't quite figured out how I'm going to build it. But what you can do instead is you can run a raw SQL query that does that ranking. We'll do that. We'll go to View and Edit SQL. Let's stick that in and run this query. And this, oh, hold on. Actually, I'm going to put rank first and get rid of the body column, just so we can see that it worked. There we go. Look at this. Asynchronous generators is the top result. Then generators, attributes, and exceptions. Resource release support for generators. This column here is the SQLite scoring column for how relevant it thinks that document is. We scroll down to the bottom. That looks about right to me. Like asynchronous I/O support presumably mentions generators, but it's not as relevant to our search term as all of those other things are. And as before, we can click hide on this and then send somebody else a link. And now we've built a search engine, and there's a search interface. They can type the search query in here. They get the results back ordered by rank. The query here, I won't go into detail, but you can see that the way this works is it's a join. So it's joining the PEPs column against the PEPs FTS column on that magic invisible row ID thing. So when we created the search index, we actually created it such that the row ID in the FTS table matches the row ID in the other table. And then when you say where PEPs FTS match : search, match is a magic sort of SQLite operator that does all of the work of running those full text queries and stemming things and all of that kind of stuff. And then PEPs FTS isn't actually a real table. It's a virtual table that exposes that relevance score right there. So it's one of those things, you can just trust me that this is the weird incantation that you need to do relevance-based searching. But it does make a sort of logical sense once you start digging into how the internals of this search system works. Search, exactly. Well, if you say PEPs FTS, so that's the name of the table, it will search against all of the columns in that table that are... it's all of the columns in that table that have search enabled on them. I think you can say PEPs FTS dot title. How many results did we get? We got, I'm going to get rid of that limit as well. So if we run this without a limit clause, we get back 42 results. If we say PEPs FTS dot title, now we get back 8 results. Yeah, so you can optionally tell it that you just want to match a specific column, and now it's just the ones where the title column mentioned that keyword. Whereas previously we were seeing everything where either the title column or the body column mentioned it. There's, I mean, basically, this is if you want to build a really advanced search interface. You know, if you want to say to people, if you want to have actually in your UI something that says search everything, or just search the title, or just search the author. I very rarely use it. For the most part, I'll just I'll run my search against all of the available columns. But it's a capability that's there if you need it. But yeah, so let's see where we've got to then. We started out with we had that GitHub repository with all of the PEPs in it. We had to write a little bit of custom Python code. This thing here, and again, I didn't write this. I cheated and I got ChatGPT to write it for me, because it's the kind of code that I can't be bothered to write these days now that there are robots that'll do it. That'll do it instead. If anyone's interested, I might be doing a open space session later in the conference talking about all of the weird things you can do to get GPT-4 to write code for you. And this will be one of the examples I'll demonstrate then. But yeah, so we did this. We looped through all of those files, and we turned them into a list. We inserted them to a database table. We enabled full-text search. We basically ran 3 lines of Python, and now we've got a search engine against all of the Python PEPs. And that's I do this kind of thing, honestly, on a daily basis. If I've got any data about anything that I think looks interesting, I'll probably slurp it down, fire it through SQLite utils, and start exploring it in this way. It's kind of my it's one of those things when all you have is a hammer, everything's a nail. When all you've got is SQLite utils, SQLite Python, Jupyter notebooks, and dataset, everything is a problem that fits into a SQLite database. Exactly. Yeah, I'm not a very heavy pandas user, because I find that I prefer SQL, and especially with dataset giving me an interface on the top of it. It's just that it's what I do habitually, and it's partly. I mean, it's mainly because what I build is almost a competitor to pandas in terms of there are problems that you could solve with SQLite and dataset, or you could solve them with pandas, and so I tend to lean towards the ones that I'm building. Like a lot of the stuff I'm showing you here, you could solve very effectively in pandas, and it would be a sensible thing for you to use it for that. Why do I need? Well, if I'm using SQL instead, do you mean? Why do I need Python? It's for the manipulation. The bit that you couldn't do in SQL very easily is this bit here, the bit where you take these text files on disk and turn them into a format and then get them in. So Python is my data manipulation and sort of cleaning layer, and then SQL is how I do the querying at the end of it. Let's publish what we've done to the internet. So I've been playing around in GitHub Codespaces, and a frustrating thing about GitHub Codespaces is that it is private. So if I try and visit this URL, here we go. So I tried to visit that in a different browser, and it says, now you've got to sign into GitHub for this. Because GitHub, they're giving us free development environments, but they're not giving us a free hosting environment for us to publish our stuff with the world. But Dataset's entire reason of existing is to help people publish data. It's all about trying to get data into a format where you can share it with the rest of the world as easily as possible. So I'm going to try something. I'm going to publish this PEPs database that we created, peps.db. Oh, it's in notebooks, isn't it? So I've got a 10 megabyte database, and I'm going to publish it with publish it to the world. And the way I'm going to do that is I'm going to use, interesting, npm install -g Vercel. Is it Vercel or Vercel CLI? Vercel, just Vercel, npm install -g Vercel. So I'm going to use a hosting platform called Vercel. And Dataset works with a whole bunch of different hosting platforms. The thing I like about Vercel is that it's the least steps to get it set up. And this is something which I would invite people in the room to try doing yourself. Even if you haven't used Vercel before, I'm crossing my fingers and hoping that this will just work for you anyway. So what I've done is I've done npm install Vercel. And the handout has all of the other ways that you can install this. There we go. I've got the Vercel command. I then have to type Vercel login. And that'll give me options to sign in. I'm going to sign in with GitHub. It wants me to visit this web page where I think I'll get to authenticate and go back again. Oh, it's got a little code for me to copy and paste in. Okay, there we go. I have now authenticated with my Vercel account. And so now I can install another plugin, dataset install, dataset publish Vercel. And this is a plugin that teaches dataset how to deploy things onto the Vercel environment. And now I could say dataset publish Vercel notebook/peps.db -- I have to give it a project name. I'm going to call it Project Peps. There we go. So what this command's doing is it's uploading my 10 megabyte SQLite database to Vercel. It's then going to deploy a copy of the full dataset web application to Vercel with, and it gives me this little link here, I think. This will actually give me a progress bar so I can see what's going on. Here we go. It's building. So it's installing some stuff. It's going to run pip install and install dataset. It's generating build outputs. It's deploying it to Washington, D.C. for some reason. It's going to run some checks, assign some domains, and it's done. And so now, if I click on peps-simonw.vercelapp.app, this is that database that we just created, complete with its search engine, so I can search for generators again right here. But it's now running live on the internet. It's on peps-simonw.vercel.app. And you can point custom domain names at it or assign aliases. There are a bunch of flexibility there. But that was kind of that was what? About 30 seconds, including installing the software, to get a database that I've been working just locally in my own environment and put it online where other people can use it. And again, this is an API. So if you want to build an application right now, the second, that runs that needs a JSON API for searching all of the Python peps, that's what this is. I'm going to stick shape equals array on the end because it gives you a nicer format back. But yeah, this is every pep that matches generators as a JSON API that anyone in the world can now start using. A neat thing about Vercel is that under the hood, it's based on Amazon Lambda functions. So it's very much a scale to zero thing where if your project isn't getting any traffic, it's not costing anyone any money to use. Vercel themselves have a very generous free tier. So it's effectively a free hosting plan for structured data. There is one catch, which is that on Vercel, the maximum file size is, I believe, 50 megabytes. So if you've got a gigabyte database, this won't work for you. If you do have a gigabyte database, Google Cloud Run works more or less the same way and can handle up to a gigabyte quite easily. But yeah, I think this is kind of cool. This was actually the feature that inspired me to create Dataset in the first place. Is I'd been looking at Vercel, which back then was called ZiteNow. It was before their rebranding, and thinking, okay, this is kind of interesting that you can host applications on this, but can this solve that problem I had beforehand, back from when I was working at newspapers, of wanting a really good way to deploy structured data in a way that people can start using it. And yeah, it works really well. I've deployed hundreds of applications to Vercel in this way. They've cost me, like, at the most $20 a month, I think I'm paying for a Vercel plan with hundreds of different projects on it. It's a really, really powerful way of sharing data in that way. Okay, so yeah, so as I mentioned, there are other options. There's a dataset out of the box, can publish to both Google Cloud Run. Oh, those two, the wrong way around, but it can publish to Heroku, and it can publish to Google Cloud Run. Heroku used to be a great option, and then they canceled their free plan, and so now it's a lot less exciting. There's my favorite hosting provider is Fly. I built a plugin called Dataset Publish Fly that can push things up there. And again, because this is based around the plugin system, if there's a hosting provider that you like that has good API-driven hosting, you can write a plugin for it.
So, sometime back you clicked on the Vercel app, on that link, that actually brought up the dataset interface.
Yes.
How did it know about that?
That's when I'm running the deploy. When you run Dataset Publish, it actually it bundles the database and the application together. So it's kind of it's actually a complete cheat. And I was going to talk about this later on, but I'll talk about this right now. The Vercel and Amazon Lambda and Google Cloud Run, they're all designed as stateless hosting providers. Like, they will run code for you on the internet, but if you want a database, they're no good. Like, they will tell you, yeah, you have to pay extra for Amazon RDS or Google, whatever Google's database thing is or whatever. Because hosting code that doesn't write to disk, that doesn't make any changes, is really easy. Right, you wrap up a little container, you launch it when a new request comes in, you shut it back down again, you scale it by running multiple copies. It's very, very easy in 2023 to host a stateless application online. Stateful applications with disk access and backups and so on, those are expensive and complicated. The big realization I had is that for the stuff that I do, I only care about read-only data. Like all of these things right here, none of them are accepting writes at all. And if it's read-only, you can essentially abuse these free hosting providers by sticking up a full database and saying, yeah, it's SQLite, it's just built in, it's read-only, it runs in read-only mode. So effectively, you're abusing their tools that were supposed to be for hosting little like simple applications, and you're sticking 5 megabytes of binary SQLite data in the container with all of the other stuff. And it just works. And this is, I'm going to talk about this at length in a moment. I call it the baked data pattern, because you're baking data into your application. But yeah, this is the sort of perfect example of why that's an interesting pattern. And with this, like a new PEP is published maybe once or twice a month. You just redeploy the whole thing. Like I have many, many projects which they deploy once a day because that's often enough to have the data that they need. And yeah, I don't worry about trying to update them in place. I just overwrite the application with a completely fresh deploy with a new copy of the database with any changes baked into that. Where did we get to? So yeah, lots of other publishing options. The dataset documentation has extensive coverage of this stuff as well. I'm going to switch gears entirely and talk about a very, very different way of running datasets. And this is a sort of experiment I did last year, again, kind of as a joke, right? So I was looking at, so there's this amazing project, Pyodide, which lets you run Python entirely in a web browser by compiling the Python interpreter to WebAssembly and running it in the browser. And then this project called Jupyter Lite is, I think, one of the most incredible pieces of engineering I've ever seen. This right here is the full Jupyter Notebook stack, like everything that the Jupyter Notebooks do on your computer, but again, running purely in the browser. This is astonishing to me. This is running Python's WebAssembly, all of Jupyter, Pandas is in there, NumPy and data frames and Matplotlib and all of this stuff. And I thought, dataset is a lot simpler than that. Wouldn't it be interesting if dataset itself could run inside the browser? And again, it was kind of a joke because Dataset is very opinionated in that it's not a JavaScript application. There's very little JavaScript in Dataset itself. There's like some syntax highlighting stuff here, but when you click sort in Dataset, it reloads the whole page. Everything is just boring old HTML because it's simpler and it's faster to load and it's got better accessibility and all sorts of reasons that I built it in that way. So I thought it would be funny if I could run a pure server-side web application entirely in the browser using WebAssembly. And so I built this thing called Dataset Lite. And actually what I'm going to do is I'm going to pop open about colon blank. I'm going to pop open my browser network tab so you can see what this thing does. And now if I go to lite.dataset.io, you can see that it's pulling down a bunch of stuff. Most excitingly, it just downloaded 2 megabytes of pyodide.asm.js and 5 megabytes of pyodide.asm.data. That's the Python interpreter compiled to WebAssembly. That's the Python standard library, I believe, compiled to WebAssembly and such like as well. And so it downloaded those two things, and then it hit the Python package index and ran a pip install of Dataset itself. And that's not actually showing up there. Let's see if maybe it's cached. I'll try refreshing the page. Loading setup tools. Oh, that's surprising. I'm not seeing it. Well, you'll have to take my word for it. This actually does a pip install in your browser and pulls the latest dataset and its dependencies in from the Python package index. And now we've got Dataset. And again, it's full Dataset. It's got all of the features you'd expect. It's got faceting, and it's got the ability to run SQL queries and all of that kind of stuff. And if you look at the URL, you'll see that it's there's a little fragment hash in it. And then everything after that point is the regular dataset URLs that you'd be using. So I built this, like I said, as a bit of a joke. I thought it would be funny. And I also thought nobody's going to use this because it has to load nearly 10 megabytes of stuff before you sit there with a loading spinner for quite a while before this becomes usable. I forgot that these days your average React app is like 5 megabytes of stuff. So, waiting for a few extra megabytes to get a full Python interpreter isn't actually nearly as restrictive as I thought it was going to be. And it's also, but the best thing about this is that this is genuinely serverless and that there is no server-side code running anywhere at all. This entire thing you're seeing is just static HTML, some JavaScript, some binary WebAssembly files. Nothing can break about this. There is no server to fill up with log files or crash or anything like that. It's actually being served off GitHub Pages, so it doesn't even cost me any money. But it gives you that full interactive experience. And so I ended up building a couple of extra features for it. I built a feature where you can give it the URL to a CSV file, or a JSON file, or a SQLite database, and if your browser can fetch it, it will fetch that file in and load it into Dataset Lite directly. And that turns out to suddenly be really, really useful. So I'll show you a couple of examples. Let's skip that one. We'll go straight to this one down here. So 538, the blog, does this wonderful thing where they publish their underlying data on GitHub. Here we go. It's the 538/data repository. And they've got, one of the files in here is called Fight Songs. And it's data about fight songs from various American college, university, and what year they were written and all of that kind of stuff. So this is a CSV file. If you copy and paste that CSV URL and hit the Load CSV button in Dataset Lite and paste it in, Dataset will fire up again. It will fetch that data from GitHub directly, and it'll load it to a table. So now we've got that dataset interface on top of data that was fed in from a CSV file via a URL. And I can do things like facet by official song, yes, no, student, writer. I can run SQL queries, all of that kind of stuff. And again, it's also bookmarkable. So if I send that link to anyone else in the world, their browser will install Dataset in Python and get a Python interpreter running and download the CSV file and load it to SQLite. And all of that bizarre, crazy junk in about 15 seconds. And then they can start interacting with the data in the same way. So I used to spend a lot of time building projects where I'd download some data, put it in SQLite, and then publish it to Vercel or to Cloud Run as a dedicated project. These days, most of the time when I've got an ad hoc data project, I'll do it by gathering the CSV data or the JSON data, sticking it in a GitHub gist, and then linking to a Dataset Lite instance that loads that data from GitHub, from gists. The reason I'm always using GitHub, like gists and GitHub for this is that JavaScript can only fetch files from servers that have a special HTTP CORS header allowing that access. Most hosting doesn't have this. So if you feed this URL to most of the things on the internet, it'll just give you an error. But GitHub do have that header turned on for all of the content in their repositories and in their gists. So GitHub is effectively the world's quickest CORS-friendly hosting provider for any kind of data that you want to throw in there. I'll show you one more example of this. That's a great question. Is there an attribution thing? There is not, and there should be. One thing that I've not, so Dataset itself has attribution built in. There's a metadata mechanism where you can configure it to show data source about license information. Dataset Lite doesn't have that yet because I'm lazy and I haven't built it, and I should build it. It's kind of rude that I've not done that yet. So I'm going to show you a project I did a few days ago using Dataset Lite. One of my hobbies is digging into the training data behind weird AI models to try and understand how they work. So this new training set came out 2 days ago called Red Pajama, and they basically released 2.6 terabytes of data that you can use to train a language model. All of Wikipedia's in there, and all of Archive, and lots of GitHub data, and Stack Exchange, all of this stuff. And so I wanted to do a little bit of an investigation about this data, but I didn't want to download 2.7 terabytes of stuff from the internet. The way they released that is they released a text file with 2,000 URLs in, And each of these URLs is a 1 gigabyte blob of data. So if you want all the data, you run wget and you download all 2,000 URLs and you take up 2.7 terabytes of disk space. But I realized that what you can do instead is you can do an HTTP head request against each of those URLs to get back just the size in bytes of each one. And that you can run in 15 seconds. You can knock up a quick script, it'll churn through all 2,000, get their sizes, and now you've got URLs and sizes. So what I did then is I turned that into a JSON file. Where is it? This JSON file here. So yeah, I dumped that out into this JSON file. So this JSON file has 2,000 records in, and each one has the URL and the size, and then I made it in megabytes and gigabytes as well, just because I was feeling lazy, and it's got the path, and then I split out the top folder because that tells you what the source of that data was. And so now I've got that gist, I can go to dataset lite, I can feed it in that URL, and now I've got a table. And so this is very, very quick route from a list of those files to a list of those files and those sizes to a JSON gist, and now it's an interface that I can start playing with. And I can do things like facet by top folder and see that in this data, Wikipedia was a single file because they put all of it in one Wikipedia file. C4 and Common Crawl are the two most represented things in that list of data. Again, I start with from raw data to starting to tell stories and understand that data in as few steps as possible is the goal here. And I'll use this demo again in a moment when we start talking about some advanced SQL queries. But yeah, so Dataset Lite is actually, it started as a joke. It's now my default solution for when I want to start publishing and working with anything that's sort of, a few thousand records, anything small. I'll do it in a gist, and I'll load that into Dataset Lite, and I won't even have to think about provisioning servers or deploying a server-side Python web application anywhere. Oh, one last feature that's kind of fun. Dataset Lite supports plugins. You can when you construct a URL to Dataset Lite, you can include $install equals and then pass it the name of a plugin. And you can do that multiple times. You can say install equals this and install equals that. And it will then, on startup, it will pip install that plugin. And so now we've got a new feature. Here's the copyable plugin I showed you earlier on. So again, if I want LaTeX from this test table right here, I can do that. I can do that directly just by passing install equals dataset copyable in the URL. I think here we go. The further reading documentation here includes links to a blog entry where I talk about how the plugin support works and all of that kind of stuff. But really, the goal here, this is an ecosystem thing, right? I've got Dataset, I've got people building plugins for Dataset. If Dataset Lite can also benefit from those plugins, then it just sort of multiplies the value that the ecosystem can provide by making sure that bits written for this aspect of it work here and all of those kinds of things. Yeah. So the question there is, how much data can your browser hold? So I have not tested the upper limits of this yet. I think it's gigabytes. And the reason I think it's gigabytes is that the other day, somebody released, so I'm fascinated by large language models, ChatGPT and all of that kind of stuff. A few days ago, somebody released this thing called WebLLM, which runs a ChatGPT style model entirely in your browser using not just WebAssembly, it's WebGPU, which is a new graphics card thing that Chrome's got. And that thing, I ran it on my browser, and it was a 2 gigabyte model file that was loaded into the browser, and it worked. So I've got to believe that a 2 gigabyte SQLite file would work fine as well, which is kind of, this laptop has 64 gigabytes of RAM, so, a 2 gigabyte browser tab isn't actually a big deal for it. I'd assume so, yeah. It's the download speed is the bigger problem, but to be honest, my internet connection at home will load 2 gigabytes in like a minute or two, so it's feasible. It's surprising how much you can get done in a browser. Okay, let's skip to Advanced SQL. We're going to talk about, and I'm not going to teach you everything there is to know about SQL in the next sort of 20 minutes, but hopefully we can cover some of my favorite advanced SQL features with enough details that you can sort of dig into them more later on. The first of these is, I mean, it's hardly even advanced, but it's something it sort of helps build things up later on, and that's SQL aggregations. We've seen select queries. Select queries are very straightforward. And aggregation is a way of calculating, sort of doing calculations across groups of rows together. The easiest example is here we're looking at the executive terms table we saw earlier. So we're saying every presidential term, I want to know for each party how many presidential terms did they get. So Democrat Party got 5, Democratic Party got 21, Democratic Republican, who I've never heard of, had 7. But the key pattern here is you select, you do a group by at the end to say, group those rows so that into sort of chunks where on that matching column. And then you can do aggregate functions like, in this case, count star, to do a calculation across those individual groups. There are a whole bunch of aggregate functions you can use. Count star is the most common. The other ones that I use is that I tend to use are max for the maximum value, min for the minimum value, and sum to add things up. And I wanted to show you dataset light first because when I was exploring that training data, something's gone wrong. Oh, look at this. There's ampersands where there should be. And yeah, there's an escaping bug. Okay, but yeah, so here we go. So here I'm running a aggregation across the top folders column here, and I'm summing the total number of gigabytes as total GB, so I can see that Wikipedia is responsible for 111 gigabytes in the data across just one file. Stack Exchange is 74 gigabytes in one file. GitHub is 212 gigabytes across 98 files. These are useful things to be able to calculate. So it's worth exploring aggregates and knowing what they can do and how you can apply them. I'm going to show you a much more fun one of these. So SQL, there's a concept in SQL called subqueries. And I missed this for years because for the first 10 years of my career, I just worked with MySQL, and MySQL versions prior to, I forget what, didn't support this feature. So I didn't know that this was something you can do. And of course, SQLite and Postgres and all of the other SQLs have really good support for this. So what this lets you do is it lets you do things like this. You can say, select something from so-and-so where repo in. And then normally when you're doing an inquiry, you give it like a comma-separated list of values. But here instead, I'm giving it another select query. So I'm saying where the repository is in the list of IDs from repos, where full name is in the list of repos from plugin repos. So what I'm going to do is grab all of that, run that here. I'm actually going to run those as separate steps first. So if we say select repo from plugin repos, you see you get back a list of names of repositories just as strings. If I then do select ID from repos where full name in, that full name has now been turned into an ID. And actually, let's do ID, star, just to show you what else is going on in there. So there's that name, and I'm saying I want the IDs for the things in this where the name is in that other table. This is the kind of thing that you could normally do with a join, but I actually find that joins across multiple tables are quite difficult to follow. I feel as reading a SQL query, anytime I get to a join, I have to think about it. If I'm using these bizarre, weird nested subqueries, I can actually follow this a lot easier. I can say, okay, I get this. It's the name of the repo is a list of those, IDs, a list of those, and then this is select the URL from releases where the repo is in that. And when you run this query, what I'm getting back is the URLs to the releases, the most recent release, because it's ordered by created, the most recent releases of the repositories that are in my list of plugin repositories. So this is, the Dataset website has two types of things it cares about. It cares about plugins and it cares about tools. If I switch that to tools, I will see, maybe it's tool repos. Now I'm seeing like Swarm to SQLite and Apple Notes to SQLite and DB to SQLite and so forth. If I do the same thing from plugin repos, I get it back as the latest releases of my plugins. So it's a little bit of a convoluted example. I probably should have broken this down into a simpler example first. What's the question there? I can do select star. No, that would be a neat feature. That's a really good idea for a feature. Yeah, if you could select just a portion of this and run it on its own. But yeah, that's not something it can do. So that's one type of subquery. The other type of subquery I think is even cooler. And that's this type here. So what I'm doing here is I'm saying for each of my where are we? For me, each of my repositories, I would like to get back the name of the repository, and I want to get the URL of the latest release in that repository. But the latest release is over in some other table. And I can actually, in my select clause itself, say I want back full name, and then I want this complicated query here. It has to be limit 1, because otherwise it'll... Actually, what does happen if you get rid of that limit 1? Let's have a look. Oh, I was expecting that to break, but it didn't. But the key idea is that for each of those repositories that we're listing, we're running a second SQL query inside of the loop to try and fetch additional related data about it. Looking at this, my instinct is that this looks like a terrible idea, because surely you're telling it to pull back 200 results and then do another 200 SQL queries on top of that to pull in extra details. I believe SQLite optimizes that to a certain extent, but more to the point, if you've got a database table with 200 rows in it, there is nothing you can do that will cause it to take longer than a fraction of a millisecond to run those queries. So often I will deliberately write very inefficient queries of this kind of shape, because I know that for the size of data I'm working with, it honestly just doesn't matter. When I worked for a larger company, I had access to Hive and Presto and various big data warehouse things. And the fun thing I found about those is you can actually write very inefficient SQL against them too, because their whole reason for existing is to break up complex queries into map reduces and all of those kinds of operations. So actually inefficient queries work well against the big data warehouses as well. And then I would never do this in production code for a high traffic web application. That's where I care about optimization. But for this kind of data size, I think you can do a lot of cool stuff just with laughably inefficient sort of SQL loops like this. So yeah, I often default to weird subqueries almost just to try them out and see what works and what doesn't. And so you always end up learning interesting new patterns from those. I've got one more super fun subquery example coming up in just a moment. This right here is my all-time favorite SQL feature that I don't think enough people are aware of. I think it has a terrible name. This is a feature called CTE, which stands for Common Table Expressions. But basically, it's SQL's answer to abstraction. Like when we're writing Python code, if we've got duplicate code, logic, or whatever, we put it in a function with a nice name, and that helps everything be more maintainable and makes us more productive. SQL queries are notorious for getting long. You'll hear from people who have a 500-line SQL query that was left to them by the previous employee, and nobody knows how it works, and everyone's terrified to touch it. The best way to make SQL more effective, I believe, is to break it up and using these common table expressions. And basically, what these are is a way to create a temporary table that exists purely for the duration of the current query. So the example I'm going to show here is trying to answer the question, how many presidents originally served as vice presidents? And we're doing that against this table. It's this executive terms table, which mixes the two types of office together. So we've got presidents in here, and we've got vice presidents in here. So what I'm going to do is I'm going to start by creating a table called presidents, and then say select star from presidents here. And this works, right? You could actually just do this without the CT at all, and you'd get the same result. But the thing I'm trying to illustrate here is that we're giving this select query here, which is doing a join, and it's doing a where clause, so it's actually quite a complicated query. We're giving it the alias presidents, and then later on we can select star from it here. The reason that's cool is that then we can add another one. We can say that, comma, vice presidents as, and then I'm going to do select star from vice presidents. And there's all of our vice presidents, or I can select star from presidents and get just those. But now that we've got these two virtual tables, we can solve our problem. We can say, now I want select the distinct names, so just deduplicate the names from presidents where that name appears in the list of vice presidents. And if I do that, I get back 15 rows, and each one of these people is a president who was previously a vice president, except I'm suspicious of George Bush because Americans are like reusing names, and there was a George Bush and a George H.W. Bush. So I'd have to dig into that and figure if that's actually a proper relationship or not. But the point stands that using this technique, you can take very complicated queries and at least turn them into something where, if you spend a bit of time thinking about it, you can start to understand what this is doing. I love this. I got a lot more ambitious with the problems I solve in SQL as opposed to Python once I figured out how to use this feature and how it allowed you to take much more complex logic and at least abstract it to the point where you can reason about it more reasonably, and then do joins between them and unions and all of that kind of stuff. So if you don't use CTEs, I very strongly recommend at least exploring them and trying to figure out if that's... Yep, you can absolutely do that with the self-join. I think it would be less readable. My hunch is that it would be harder to follow if you did it as a self-join. Although I'd be happy to be proved wrong by somebody doing that. So yeah, mostly CTEs they're more of a readability hack than anything else. They're a great way of making it easier to look at a query and understand what it's doing. Let's talk about JSON. I think I've got a quote so another feature that SQLite has baked in, which is incredibly valuable, is it's got a bunch of functions that know how to deal with JSON objects that have been stored in the database. Postgres has a JSON type. There's a JSON and a JSON-B type, and it's all optimized and everything. SQLite doesn't. It tells you to store JSON in a text column just like anything else. But if you do store JSON in your text columns, you can start to do all sorts of interesting things with it. More importantly, though, SQLite can output JSON. You can use functions to build up JSON values that you then return back to people. So this query right here, the thing I was trying to solve with this is I wanted to get back a list of all of my legislators, and for each legislator, I wanted to fetch all of the terms that they had served, but all in one go, right? Normally, if you were doing this, you'd have to, you might run Python code that dedupes it, or you may end up like pulling back duplicate versions of the top level thing to get one row per term. There's a bunch of ways you could do this. It's kind of neat to be able to say, you know what, I want a single row per legislator, and in one of the columns in that row should be a JSON list of objects representing everything from this other table. There's actually, there's 2 columns here. There's 4 columns. There's the legislator's ID and name. There's that JSON list of all of the terms that they've served from a related table. And then there's a number of terms as well, which is 1 there, and it's 13 here, and it's just a count of what's going on. So the way I'm doing this is 2 tricks. Basically, this is an aggregate, like I showed you earlier. So it's select these things, group by legislators.id. So I'm deduping and grouping on that ID of the legislator. And it's a join against legislator terms. So I've actually got duplicate records for, in fact, let's show you the duplicate records. I'm going to do this as select star from legislators join that and get rid of that group by. So the actual data that came by is full of dupes, right? Like Watkins Abbott is represented 13 times because Watkins Abbott has been has had served 13 terms in Congress. The first step is that we group by legislators.id to dedupe those things. And we do let's do a count star here. And so that gives us back just the ID and the name and then the number of terms that they served. So 13, 4, 3, 5, 1, 1, 1, 5. Oh, there's a limit 10. That's why I'm not getting back more than those first ones. Let's do this again. So there we go. Those all of our different legislators with all of those counts. And then the real magic here is I'm adding an additional aggregation called JSON group array. So what this does is it says for every duplicate, for each of those duplicate sort of chunks of rows, build me an array that joins them all together. And in that array, I'm going to put a JSON object. And the JSON object is these labels and these columns. So I'm building an object for each one with the type and the state and the start and the end and the party. And you can see that in the output here, where you've got type, state, start, end, party in those JSON objects. So the problem we're solving here is if you've been a web application developer for a long time, this is something that's it's always frustrating. Like, I want to pull back all of my blog entries, and for each one I want a list of the tags on that blog entry, and I don't want to have to run multiple SQL queries to retrieve back those tags. Once you figure out how to use JSON aggregations like this, you can solve one of the sort of most frustrating problems in web development with a SQL query that does all of that fetching for you. I wrote about this quite extensively in this article linked here, returning related rows in a single query using JSON. And this actually shows you how to do the same thing in Postgres as well. So if you're a Postgres user, it looks slightly different. Here we go. It's JSON ag and JSON build object. What's that? Yes. Yeah, so here's the exact same trick done in Postgres. Same idea. The syntax is very slightly different, and there's a coalescing thing that's explained in this article too. But yeah, it's a really powerful trick, and it's one of my favorite sort of advanced SQL mechanisms because it solves this problem that I've fought so many times as a developer just building standard web applications. Yes. So we talked about CTAs, we talked about JSON. This is the final advanced feature that I wanted to mention today. This is something called window functions. And okay, the problem that these solve is, this is sort of a much more powerful analytical problem where you want to do things like rolling averages over time, or look at, this is specifically important for things like time series data, where you need to do rolling averages or some things by a sort of, but in chunks of your data as it moves along. The best way to explain this is to start with this thing here. What happens if I get rid of that? Okay, so the problem I'm trying to solve here is I would like to return I want to return, for every repository in my database, I want the name of the repository, the date of the most recent release associated with that repository, and the 3 most recent releases as a JSON array. So previously, I showed you the example with the JSON where we were returning everything. For each legislator, we'd return all of their terms, and we'd hope that none of them ever served 1 million terms because it would have broken our query. Here, some of my projects have had over 100 releases. I just want the 3 most recent returned in this query. So we're going to start with this query here. This is a join. We don't even need the CTE for this. Here, I'm joining the releases against the repos table and getting back all of that data. And you see there's more than 1,000 rows because dataset itself has, oh God, how many releases has dataset had? A lot. Like, this is the sort of raw data that we're going to start working with, but there's a lot of deduping that we need to do here. What I can do next is I can, I'm going to add a rank. So in order to select just the 3 most recent, it would be useful if I had an indication of the sort of incrementing integer for which release that was for those projects. So I'm doing that by adding this little magic piece of syntax here. And this is what SQL calls a window function. It's a feature that was added to SQLite maybe 3 years ago, inspired by its implementation in Postgres. What I'm doing is I'm saying, for each of these releases, I want you to create a partition that's unique for each of those repository IDs and is ordered by that created date on those releases in descending order as rel rank. Hard to sort of see what that means, but if you look at the output, what we've just done is we've added a column here, this rel rank column right at the end, and it keeps on going up for all of dataset's releases. Dataset has had 125, and then we switched to CSVs to SQLite, and that's only had, wow, how many? That's had 13 releases, so it goes 1, 2, 3, 4, 5, up to 13. Now on dataset cluster map, that's had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this has now given us, in this single table for this single result, we've now got something else that we can filter on to say, I just want the top 3. Although, are we in the correct order here? I think we're in the wrong order. No, we are in the correct order, aren't we? We're starting with the most recent and going down. So now what I can do is I can say select star from CTA where oh, I've switched back to US keyboard layout. Where rel rank greater than or equal to 3. Oh, no, it's less than or equal to 3, isn't it? And this has almost solved our problem for us. We're now saying, for each of these repositories, just show me the 3 most recent. So for dataset, we get 3 rows for versions 642, 641, 64. CSVs to SQLite, we just get 3 rows. 3 rows for cluster map, etc., etc., etc. Somewhere in this, our DBF to SQLite has only ever had 1 release, so it only shows up once. But most of the others, we've had at least 3. Dataset cores is another one with just a single release. But this is almost what we need, right? This is, if we want the 3 most recent releases for each package, we've now got that data, and the last stage is to add that. Here we go. And again, I'm taking advantage of my common table expression for this one. I'm adding back in one of those JSON group arrays with JSON object, and that worked. So now for for the dataset repo, there's 125 releases total, but there's only 3 that we care about in the recent releases, and that's those 3 that are showing up here with the ID and the name they created at. Again, quite a complicated query, right? We're getting quite a lot of stuff done with this, but by combining the CTE mechanism with the JSON group array mechanism with the window functions mechanism, we're able to do get a pretty sophisticated result out that if we wanted to build a custom application that shows us that sort of summarized data, that's most of the work done for us just in this one SQL query right here.
So, what is the computational cost of doing that JSON aggregation in SQLite?
That's a great question.
Versus like in Python or in whatever other programming language?
So the question is, what's the computational overhead of doing the JSON construction in SQLite as opposed to in Python? I have not measured it. My hunch is that SQLite's faster. Because SQLite, everything in SQLite it's all C. It's incredibly well optimized. The benchmarking they do on it is absolutely extraordinary. My hunch is that, and the thing I have benchmarked is things like how fast can the JSON functions in SQLite crunch through gigabytes of data. And it's just astonishingly fast at processing things. I've actually got a quote from Paul Ford that I dropped into the section here, where Paul Ford, when talking about SQLite's JSON support, said, the JSON interface is like, we save the text, and when you retrieve it, we pass the JSON at several hundred megabytes a second, and you can do path queries against it. Please stop overthinking it. This is a filing cabinet. Paul Ford's trick that he uses all the time is he gets JSON from somewhere, and he literally just loads it into a SQLite table, which has 1 row per object with a blob of JSON, and that's it. And then he uses SQLite's built-in JSON features to extract bits of it out and convert things and all of that. And he'll often then save the results to a new database table, but do all of his data processing with JSON functions inside of SQLite itself. I'm not quite there yet. I haven't embraced it to quite that extent, but it is a phenomenally performant way of working with data. And I feel like most data these days comes in JSON shape. If you've got a database engine that can do JSON really well, and SQLite does do JSON really well, you find yourself leaning on that more and more. Like, I always try and get things into a relational table eventually, because then you can do faceting and filtering and all of that kind of stuff. But there is a lot you can get done just using blobs of JSON if you've got a fast C library on top of it all. Okay, we are running close to time. I can just finish this last section. I wanted to show you some more fun demos, the kind of things that I've been building Dataset with. And basically, this is a chance for me to show off some of my websites that I like. So the first website I'm going to show you is, this is the website for my main hobby outside of technology. I basically collect tiny museums. So the goal is, whenever you're in a new city, and I've never been to Salt Lake City before, and there are some very interesting tiny museums around here, try and find the smallest museums and go to those first. Because if it's a really tiny museum, it doesn't matter what it's about. The chances are that the person who collected the stuff is there running the museum, and then you get to have a conversation with somebody who collects evidence of Bigfoot or Pez dispensers or little devil statues or whatever it is. It's super, super rewarding. So this website is where I put all of the tiny museums that I've found and gone to. And you can actually say, use my location, and it'll show you, oh, the Donner Memorial State Park Visitor Center, 450 miles away, is the closest that I've been to here. So I've clearly not explored Utah and Colorado at all yet. But anyway, this is just Dataset. This website right here is the same Dataset web application you saw earlier, but Dataset lets you use custom templates. And so here I've got a custom template for the homepage that makes it look like a website about museums. And I've got, this is a custom template that knows how to put things on a map, and the search feature is just another canned query. And you can tell that because if you go to nichemuseums.com/browse, it's Dataset. This is the website. There's the museums. I think this one, it's deployed on, it's got plugins, all of that kind of stuff. It's deployed on Vercel, so it costs me nothing to run. Every time I add a new museum to it, it deploys a new version of the site, which works just fine. But the one thing I did want to show you is that this website has an RSS feed. So you can click there and you get XML back that you can subscribe to in a feed reader. That's actually defined using a SQL query. There's this query called browse/feed. It's this giant monstrosity of a SQL query here. It's using JSON each and coalesce and all of that kind of stuff. But the output of that query is this table. It's got columns atom ID, atom title, atom updated. And then there's a Dataset plugin called Dataset Atom, which only fires when a table has these columns. And it adds the .atom extension, and it turns that into XML. And I've actually got a few other plugins along those lines. There's one called Dataset ICS that can output subscribable ICS calendar files. It's kind of fun. I'm effectively using SQL as an integration language where, as developers, we spend so much of our lives getting data in one format and transforming ever so slightly into another format. SQL's really good at that. You can say select something as atom ID, something as atom link, and it'll transform it into that other format. And then if you've got plugins that know how to output things in different shapes, you can sort of pipe it all together, and now you've got a sort of an out-of-the-box engine for reformatting data into different formats, which is something I've played with a whole bunch and I think is really neat. I'm going to skip my other example from this section and jump to one last thing, which is a project that sort of illustrates what happens when you pull all of this stuff together. So I've got a blog. This blog I've been running for 20 years. It's been a Django app for most of its life. It's a Django and Postgres, and it runs on Heroku. And that's really cool. It works. It's got the Django admin and all of those features. But these days, I like to do things with SQLite and Dataset. So I have a copy of my blog running at dataset.simonwillison.net. This is my blog as a SQLite database. And the way that works is I've got a GitHub Actions script running here, which, let's see, this runs, 26*/2? Can anyone remember what that means? Is that every 2 hours? Yes, so this runs every 2 hours, and every 2 hours it grabs a backup of my database from Heroku as a Postgres dump, and it converts that into a SQLite database, and it just gets those tables, and it, I think it redacts the password column because I don't want the password column out there, runs a few little transforms to drop a few tables, blah, 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 blah. And then at the end, it runs dataset publish. Where's the dataset publish bit? Somewhere way down here. There we go. Dataset publish cloud run simon-wilson-blog.db with a bunch of extra options, and it installs a bunch of plugins. But effectively, every 2 hours, the latest version of my blog gets published to a dataset instance here, which means I can run SQL against all of my stuff and run queries and searches, and all of the sort of dataset goodness is available to me. But what I wanted to do is I wanted to start a Substack newsletter because I wanted people who only ever use email to be able to subscribe to my blog. But I didn't want to do any extra work. Like, I'm already putting stuff on my blog. I wanted the simplest possible way of getting my blog's content into newsletter format. Substack do not give you an API. Like Substack, they give you a text editor, a rich text editor to write content in. They do not give you anything to help automate that process. But you can copy and paste things into the Substack editor. So I'll go here, I'll go new post. Here we go. This right here is quite a good rich text editor. It can do bold and links and headings and images and all of that kind of stuff. So what I did is I built myself a tool using an observable notebook called Blog to Newsletter. And this is basically a giant bundle of JavaScript which hits the dataset API on my blog, fetches back all sorts of different bits of content and all of that kind of stuff. I think it's actually... there's a terrifying SQL query in here somewhere. Here we go. This is the SQL query that I put together, which reads from 5 different tables and glues things together and sorts by and collects and all of the CTE tricks and all of that kind of stuff. And based on running that thing there, I get this table of data. So this has my titles and my URLs and different types of content and so forth. And then I've got a bit of JavaScript at the top that glues it together into Markdown. Is it no, it's HTML. So that generates HTML. This previews the HTML. And then this right at the very top, I've got a big grey copy button. Actually, let's do... Here we go. So I can click copy. And then I can go to Substack and hit paste. And that's my newsletter. I'm done. So in this case, I'd do that title there. I'd stick that in the title up at the top. I add some kind of subheading, and I click send, and it's done. And this has meant that sending out my newsletter, which I do once or twice a week, takes about a minute and a half, like end to end. But if you look at the moving pieces that are going on here, this is my blogs in Django, and I've got the GitHub Actions that are pulling it from Postgres and converting that to SQLite, and then I publish that to Google Cloud Run, and then I run JavaScript and Observable to pull it all together. But it kind of just works. You know, once I'd pieced those bits and pieces together, and one of the things I like about using observable notebooks for this is I don't even have to like commit code to GitHub or open a text editor. All of the like the hard work that I did in here was done just directly in this notebook interface right here. So it's kind of cool, and I think that's a nice sort of illustration of what the kind of projects you can do once you've got all of these different components working together. So we've only got 3 minutes left. I've covered everything that I wanted to cover. Let's do 3 minutes of questions. Yes, there's one there towards the back. Yeah.
Earlier, when you published the PEP project, and you had that, just the 429 PEPs on the website, you share the link. If you want to do some pre-work for your audience, and say you want to materialize some views, like here's just the final, here's the deferred versions,
Mm-hmm.
are those reading from the same base storage, or do you have to compound storage?
Yeah, there's something I didn't get into today is that Dataset actually supports, SQLite supports views, right? SQL views. And there's an example of one here on the Dataset website. This is a view, this is the recent releases view, which does a join between the releases and the repos table, a bunch of the stuff that we were playing around with earlier. But because it's defined as a view, Dataset treats it just like another table. So you've now got the same interface. You can like facet by topics and order by date and get things out as JSON, all of that kind of stuff. So it behaves exactly like it was a table, except that it's defined as an extra SQL feature. And that's super. That's something I find myself doing a lot. Is I'll get a bunch of raw data in a normalized form, and I'll use the views to create those sort of denormalized convenience layers. And then you can get that out as JSON as well. So if you want a JSON API for a very specific shape of data, one of the quickest ways to do that is to define a view and do it that way. I'm going to stare at people until I get one more question. Oh, yes, there.
Just kind of architectural question. You mentioned like DuckDB, like, well, I don't want to support both of them, but what about just doing it on SQL Alchemy?
Oh, yeah, so if I don't want to build a database abstraction layer, what about using SQL Alchemy? It's a good question. I've never quite gelled with SQL Alchemy. Like SQL Alchemy, it's big and complicated. And so with dataset, I've kind of been trying to minimize my dependencies. My biggest dependency for dataset is Ginger, the templating language, which I feel has sort of proved itself over many years. And to be honest, SQL Alchemy has proved itself as well. I don't think I'd be making a mistake to lock myself in SQL Alchemy. The thing I'm worried about is dependencies where they might have backwards incompatible changes next year and all of that kind of stuff. But yeah, it could be that SQL Alchemy would help solve my database abstraction problem really well, but I've just not really dug into it enough. My hunch at the moment is that dataset actually doesn't have many bits of it that would differ between different databases. It's mainly the way the table page works, which is at least quite isolated. Like I'm refactoring that code at the moment. So I'm thinking maybe pluggable database backends wouldn't be as difficult as I'd initially thought they were. And if I do pluggable database backends, the first two are going to be DuckDB and Postgres. Because I feel like if you can do those two, that's 90% of the world, of the sort of data problems in the world fit into SQLite or DuckDB or Postgres. Okay, well, we're at time, so thank you all very much for coming along. I will be hanging around here for another 15 minutes, happy to talk about the stuff more. The handout will stay available forever. I'm going to update it. I'll probably turn bits of it into more official dataset tutorials as well. And I'm super keen on feedback on this stuff, like anything that didn't make sense, anything that could be easier, ideas for future projects. I want to hear all of them, and I'm here for the rest of PyCon. So again, thank you very much.